For sure. Watch your step, but Miss Athena's in here.
Hello. Hi.
Hi there.
Nice to meet you. What's your name?
Thomas.
Thomas. Very nice to meet you.
I watch you guys out of Sacramento. Excellent.
Oh.
Okay, for whatever reason, I'm not hearing anything right now.
I'm
I
sorry.
don't know if you guys put yourself on mute.
Yeah, I've got audio
Did you
controls. I've got audio controls.
Okay.
On muting stuff.
All right.
There's a bunch of confusion going on, so I'm trying to eliminate that.
No, your ears are up.
You can never eliminate confusion. You can only control it.
Good morning, or afternoon, or evening. I am sparkly again.
I always like that greeting from the Truman Show. Good morning.
Good morning.
And if I don't see you, good afternoon. Good evening. Good night.
Yeah, that's always fun. Oh, that's awesome. For Keep. Where was that? You had almost 500 people attend our meeting to watch the moon eclipse. How many of you guys got to see that? How cool is it? It was like super, super long. So yeah, so where were you watching that from? For Keep. For Keep. For Keep. I'm just testing out different pronunciations. I don't even know if my mic's on. Yeah, it is.
There we go.
Space mic.
Whew.
That's hilarious.
Hello.
Maybe I should have just typed it.
Man. Whew, almost didn't make it.
Oh, I gotta turn that up.
Technical difficulties were difficult.
Oh,
Understood.
that's why they're not called technical
Easies.
easies.
Wow.
Thank you. I couldn't think that. Something else.
Everyone scooch
Oh, man.
I forgot how sketchy the table was.
Hey, I made that table in 5 minutes.
It doesn't show.
Let's see here what we got.
Yay. Okay.
All right.
Well, I'm based off of that.
You just stand where you need to be.
I don't know where I need to be.
Let's go to space.
Oh, jeez.
I love how in character you get with being a hologram. It's amazing. Wait, no laughing.
You got it. You got to sell it, right?
It's not no laughing.
Not no laughing, but did you go back and review the?
I did.
Jared,
you play the fun
Jared, do you have ears in?
Google challenge where if you move your point.
I do have ears in, and I have my mic on.
Okay, guest is available for name pronunciation.
Yes, Bruce, I'm Jared. I'm going to be interviewing you today, and I was just wondering if you could tell me how to pronounce. Hello, here's me. I was just wondering if you could tell me how to pronounce your last name, so that way I could say it correctly on air.
It's pronounced Bannert.
Bannert. Okay.
So it comes out almost like Bruce Banner, but just tee the end a little bit.
One of our folks on here this morning was saying that. So, so excellent, yeah. Bannert. All right. So sounds perfect. Is there anything that you don't want to talk about today during the interview? Is there anything that you feel like we don't really want to hit that subject?
5 minutes up.
Politics is probably a bad idea.
Yeah, well, in general, we we try to stay away from that as it goes. So yeah, yeah, that's.
But yeah, you can ask me about anything. If I don't want to talk about it, I'll tell you on there. So
Okay,
I
that's fine.
can't think of anything off the top of my head. Got nothing to hide. Nothing to hide.
Yeah, I was just gonna. One of the things I know I'm gonna talk about today is sort of the seismometer delay and kind of how you guys handled that and things like that. So,
Okay.
so as long as that's kosher to talk about,
Sure.
we'll definitely talk about it.
Look to me.
Hello, Ben. Ben, that is an exquisite shirt that you are wearing today, and I actually kind of want it.
Target.
Target?
Yes,
Wow.
Thank you so much. Hey, Jared, I need you to hold this to this camera.
Okay, ready? All right. Wait, am I holding this or the other side?
No, you got it. That side.
Okay.
1 second.
This other side is hypnotizing me. Oh.
Hold it there. I need you just to awkwardly hold it. For me.
Sure. Yeah, I can awkwardly hold things for as long as need be. Wow, this back focus test pattern is making me slightly dizzy to look at. So.
Close your eyes then.
Well, I guess I can't be a pilot.
Oh, I didn't explain to our guest about the cold open.
Jared, drop it for a second. Bruce, when we start the show, we will toss to Jared to talk about, introduce your interview, and it's just a quick little. I'm Jared, and I'm going to be interviewing Bruce, etc. And then we'll go into a open graphic just before our news. Just be prepared for that. You don't need to say anything.
Okay.
You're just going to be pretty on screen.
Perfect. Thank you.
You're getting sleepy. You might want to mute me. I gotta attach my.
So one thing I don't get is it's like a 2-second delay on the display screen. Is that going to be weird?
We usually don't show you on the display while you're talking.
Okay.
So it might be a little bit weird when that happens, but when you're talking, we usually go full screen.
Okay.
Room temperature Coke.
Alright.
That's fine.
That sound was so detailed. I could hear the water going down.
Sorry.
Yep.
Or the Coke going down.
No, that's Jared.
Yep, that's me. Food noises. It's making yummy sounds. Rockets and launches.
Oh my gosh, yes. My favorite things, but for rockets. Is there a version of that?
I mean, I feel like we just started one.
If it doesn't exist
Atlas
already,
and
we have to
Delta
do it.
and Falcons and Soyuz.
There's a Coke. My Coke can is in frame. Hey, Lisa,
Okay, let's see.
could you grab this? I'm sorry. Hold up.
That's why I'm here.
Write this
I'm not
down.
on the show, it's time to run it. It's fine.
Top it off. They're playing shuffleboard with a ton of objects in the studio right now. I just shuffled my phone. I just did my IFB case.
Hi, Dad Dog.
What should I do next?
Score?
Dad dog.
Oh. That dog in the house.
All right, we are 1 minute. Uno mas.
Hey, thanks. I got this with Chris Radcliffe.
Nice.
Kind of, sort of. I was there with Chris Radcliffe and Mr. Bing, but, all right, I'm
Is that
ready.
up in Skedaddle?
Welcome to Station 204. Ah!
You ready?
I am.
Ready?
Let's do this.
Let's see how rusty I am.
Welcome to tomorrow. I am Carrie Ann, and I will be your Capcom for the day. The rest of our team is Athena, Mike, and Jared. Now, today in news,
We have water on Mars.
oh, and Mike?
Oh, man. Commercial crew excitement is exponentially rising.
That's totally what the script says. And on the observation deck, we have Jared.
Yes, and I'm going to be interviewing Bruce Bannert, the principal investigator of NASA's InSight mission to Mars.
Awesome. After all of that, we'll all come together and talk about your questions, comments, concerns, complaints about our last show. But this is Tomorrow, Orbit 11.29.
Good morning. How's everything up in the sky?
So good. Athena, during that little open said I meant to say liquid water, so just keep that in mind for a little bit later when we talk about it. But at first, I want to make sure I give a huge thank you to our Escape Velocity citizens. These are the people who contribute $10 or more per episode, and really, they hang out with us. They get access to our exclusive citizen-only hangouts, which is what we did last week. They get free worldwide shipping in the Tomorrow Swag Store, access to Escape Velocity Discord channel, where new show ideas are born, and honestly, so much more. They get to be in the middle of all the crazy. And while you're here, don't forget to hit subscribe on YouTube and hit the notification bell so you know when future live shows are happening. Then that is really what counts. We just like hanging out with you. So head on over to patreon.com/TMRO. Oh my goodness, we haven't been on for a while doing a proper show. We did a Citizen Hangout, and those of you who are with us, thank you for joining us. It was a lot of fun. I had a lot of fun. We went over a whole bunch of new things, and there will be pictures coming soon, I promise. But Mr. Mike, we have a couple of launches to talk about. And I say couple almost jokingly because there's more than a couple, of course, because we haven't been on for a little bit. And I know you like to go in chronological order. So what's the first one up?
That's right. So the first one, normally we cover orbital launches, and this first one's actually a suborbital launch, but the footage was so beautiful I couldn't help myself.
Agreed.
We're talking about Blue Origin's Mission 9 of their new Shepard vehicle, and this launched on Wednesday, July 18th at 1511 Coordinated Universal Time from their West Texas test site.
Nice.
6, 5, 4, command engine start, 2, 1.
This was the 9th test launch of a new Shepard rocket and the 3rd test flight for this particular booster. It carried Mannequin Skywalker on board, as well as a bunch of suborbital experiments, and the hydrogen-fueled BE-3 engine generated 110,000 pounds of thrust. And during the flight, one of the tests that they were trying to do with this is they performed an in-flight abort test after the booster separation, which you'll see in just a moment here. And with that in-flight abort test, after the separation, they were able to reach a higher altitude than they ever had before with the new Shepard capsule. They reached a maximum altitude of 389,846 feet, which is nearly 119 kilometers, so well beyond the boundary of space. Oh man, it had a max speed of 2,236 miles per hour, and the entire mission lasted about 11 minutes and 17 seconds. And holy cow, for this mission, they actually had redesigned the new capsule. Oh, and we got to see this landing.
Landing gear down.
Woo! Awesome. Beautiful, beautiful footage. Oh, man. And with the capsule, too, they had bigger windows than previously before, and they've done a redesign, too, of the interior, although this capsule did not feature the new interior with the nice new seats and everything like that. But the bigger windows is going to make a big difference for the people that eventually do start flying on that. There have been a couple of updates as well. Apparently, they're going to start selling tickets, or rather, they're going to start flying some of their own people this year and then start selling tickets next year, although there hasn't been an official price set for how much tickets would cost for each person. Oh man! And after the landing, I think this is the first time that we've seen a angle of the capsule and the rocket after landing. So I thought that was just a really neat shot there that they got at the final landing. How cool would that be to be so close?
No kidding.
Anyway, really excited for this whole mission. And there's kind of the stats right there that we already went over, but. Oh man, this was just an exciting flight, and I cannot wait until they start flying people and start flying paying customers as well. The suborbital tourism space race is heating up, and I'm so excited for it.
Yeah, totally. It's funny you mentioned that shot that we probably have not seen before. I don't recall seeing it before. It's very reminiscent to me of the two space shuttles on the two different launch pads back in the day when we had that picture, which was really incredible. Yeah. And I love that they painted their bullseye blue. That makes me giggle.
That was awesome.
Right?
Yeah.
Exactly.
Yeah.
All right, there's more launches to go, so let's keep rolling. What was the next one?
Yes, there is. Let's get into the orbital launches. First off, we had a Falcon 9 launch. There was actually two Falcon 9 launches this week. The first one was for the Telestar 19 Vantage communications satellite. Let's check out the footage.
Zero ignition. Liftoff.
There it is. There's that roar. Oh, man. So this launch occurred on Sunday, July 22nd at 0550 Coordinated Universal Time from Launch Complex 40 in Cape Canaveral, Florida. And this was the second time that SpaceX has flown an all Block 5 Falcon 9, which means both the booster stage and the upper stage is the Block 5 version. And as I said, the payload was the Telestar 19 Vantage spacecraft, which is built for Telesat and SSL. And it's using KU band and KA band communications for both North and South America and the Atlantic. And it's actually being sent, this was a geosynchronous transfer orbit mission. It had a perigee, or a low point, of 244 kilometers and an apogee, or high point, of 17,871 kilometers with an inclination of 27 degrees. Now, the customer agreed to a sub-GTO mission because 17,000 kilometers is not geostationary orbit. Geostationary, or rather geosynchronous orbit, is 35,000 kilometers, but the customer agreed to it so that they could do a successful landing, which we saw the cutout there of the footage, but you saw the successful landing there of the booster, which landed on the drone ship, Of Course I Still Love You, in the Atlantic for SpaceX's 26th successful landing. And of course, the primary mission, the delivery of the satellite, was successful as well.
That's awesome. I love the little windshield wipers on the
Yeah.
Those are always funny.
That was definitely inside something, not just mounted outside.
Right? The name of it? I Still Love You?
Of Course I Still Love You.
Oh, okay. And there's another one called
Course
Didn't
I
Read
Still
the
Love You.
Instructions or something,
Yep,
right?
just read the instructions. Yeah.
Just read the instructions.
Yeah, that's
right.
the other drone ship.
I didn't know
That's
the
the
reason.
other
I was
drone
like,
ship.
oh, okay.
Yeah.
That's so funny.
I like it. I like it.
Yeah.
It's good. It's quirky. It's
Yeah.
shows character, I think. All right, and then there was an Ariane 5 launch.
There was, yes. We haven't seen the Ariane 5 launch in a little while.
Yeah.
Oh my gosh, this was really exciting. This was delivering 4 more Galileo satellites for the European Union. So, let's check it out. Oh, yeah, that's right. I wanted to include, this is my favorite part about the Ariane missions, is their whole graphic there showing the inside of the payload bay. I love how they do that. We haven't seen that in so long. I almost forgot about it until going over the launch footage for this. Oh, man. All right, so let's go ahead and see the launch itself. This occurred on Wednesday, July 25th at 11:25 Coordinated Universal Time.
Allumage Vulcain, allumage des 2 EAP et décollage vers 244.
Look at that footage. I cannot believe that. I'm not sure if we've seen views like that before for
it's
an Ariane
gorgeous.
5 launch. Oh man! Of course, this was rumbling in the jungle at the Guyana Space Center in French Guiana. Oh man, and I love it. It was actually headed into an elliptical transfer orbit, eventually headed for a medium Earth orbit. So it's similar to a geostationary transfer orbit, where its perigee has a really low point and then its apogee has a high point. What they were shooting for was around 23,000 kilometers. And the four satellites, the four Galileo satellites, were actually going to be heading into various inclinations using their own propulsion power. But look at that. We actually got to see footage from the ground of the booster separating from that. I mean, I know that's super shaky footage. It looks like I took that footage right there, but oh my goodness. I cannot believe that we finally got to see that. That's just beautiful. I mean, they've shown the footage from, cameras from the rocket seeing the booster separation, but that's just really cool that we were able to see that.
Yeah.
Something kind of special about this was that this was actually the last flight of this particular Ariane 5 version. It's the Ariane 5 ES version, which uses an out-of-production upper stage, the ES upper stage that you see there. It uses toxic storable hydrazine fuel, but it does have a reignitable engine, so they can ignite the engine multiple times. All the future flights of the Ariane 5 before they retire it are going to use the ECA version, which has an upper stage that is hydrogen fueled and can only ignite its engine once. But if you notice the timer on the top right corner there, it had a 3-hour coast stage before the ES upper stage reignited its engine and then separated the spacecraft about 20 minutes apart in pairs. So for these Galileo satellites, this was the numbers 23 through 26. And of course, the Galileo satellites are the European Union's version of GPS satellites, which complement the GPS network. And eventually, the Galileo constellation will have 30 satellites. The last mission is going to be actually launched on the Ariane 6 once that starts flying. So that was really cool.
Yeah.
But while this flight was going on, just a few minutes after the launch of this Ariane 5, we had another Falcon 9 flight that launched just a couple of minutes later.
How inconsiderate. It's like just schedule these things better.
Yeah. So we literally had two missions simultaneously going on at once. And while Ariane 5 had that 3-hour coast phase, SpaceX was finishing up their mission. So what was their mission? It was the Iridium 7 mission, carrying 10 more Iridium Next satellites. And this also launched on Wednesday, July 25th. And this launched at 11:39 Coordinated Universal Time. The Ariane 5 launched at 11:25 Coordinated Universal Time.
Nice.
Wow. This rocket launched from the West Coast, from California in Vandenberg.
Oh, wow.
4, 3, 2.
Look at that great footage.
Liftoff.
I feel like if they just had a camera that was closer, maybe.
At least we had this one right here. That was from the rocket cam, and there we are.
That
We're
is
through the
cool.
fog. All right,
come
we made
on.
it. Oh man. Now this is launching, like I said, from Vandenberg, from Launch Complex 4 East, and this was the third all-up Block 5 Falcon 9. So I wonder now if there's any pieces left of any of the Block 4s or previous versions. I don't know. But in any case, for this mission, the Iridium Next satellites were numbers 56 through 65, which provide L-band broadband internet communications for U.S. customers through cell phones, maritime, even in-flight connectivity for aircraft. But what they're heading to, their final orbit, is in low Earth orbit, around 625 kilometers, and they have an inclination of 86.4 degrees. Eventually, they're going to raise ever so slightly to get around 710 kilometers. But in any case, what the heck is going on right there? I have never seen a plasma effect like that with both the upper stage and the booster stage. So I had to just throw that in there because that just is some really awesome looking footage right there. It's like it's going through Stargate or something like that. In any case, the booster did land on the drone ship out in the Pacific called Just Read the Instructions. Yeah, the aforementioned Just Read the Instructions drone ship, which made it the successful 27th landing for SpaceX total. And just like the last mission, since it was out on the drone ship, we didn't actually see the landing itself. But in just a second here, you'll see the footage that was collected of the landing. Now, on this mission, they were also going to try to recover the payload fairings. However, Mr. Stephen, the recovery boat for that, was unable to recover either the payload shrouds because of rough seas and really unfavorable winds. In fact, I've heard some rumors that they were a bit nervous about the landing of the booster stage, or even if the landing was successful, that it was so rough out there that they might have had it tip over. But apparently everything was fine, and the booster is headed back to port, and things should be fine with that. In fact, I think it's already arrived in port, if I'm not correct. But in any case, for the primary mission, all 10 of the Iridium NEXT satellites were deployed one by one, 100 seconds apart. And I included that because we got to see a couple bit. At least we have the proof there that there was a successful landing from that shot. But
Totally.
With the deployment of the satellites, we didn't get to see each and every one of the satellites deployed just because of the angle that it was at. But you can see a couple of them. There was one in the corner there, and you see a few more popping out. All these different satellites are I love some of the angles for them. All these different satellites, as I said, are providing L-band broadband, and it's only for subscribers of the Iridium system. And this isn't something that you could log into on your cell phone. You'd actually have to be subscribed to their service. But
Wow.
an incredible mission, and I cannot believe that SpaceX turned around 2 flights so quickly. And they have another one coming up real soon. So it's an exciting time for spaceflight, and a really exciting time for SpaceX too.
Yeah, totally. This is the one that Iridium created like a Spotify playlist too, right?
Yeah, they did.
That's so cool.
Yeah, which I like that they are getting so involved in something that, I mean, they have their own product, which is, like, obviously it's the satellite stuff, but that they're like, hey, no, we want to play along too. And like, you have like the Spotify playlist that you could just sort of tune into.
That's so cool.
Timed out to what's going on. I thought that was really cool.
That's really awesome. I didn't know about that.
Yeah, neat, right?
I'm going to look that up later. Yeah.
Yeah, totally. Totally.
That's awesome.
And some decent music on there too. So in case,
Yeah.
appropriate for most ages. So liquid water on Mars is what we're talking about.
Yes.
Yeah, because I feel like, we've kind of scraped some surface quite literally and found some water ice.
Yeah.
But liquid water on Mars, that's kind of a different thing. So what's going on?
Yeah, so it actually was found underneath a layer of ice. So obviously like frozen water ice.
Yep.
So it's about 1.5 kilometers thick of the ice, and they were able to find it underneath by using radar from the Mars Express mission, which is European space agencies. It's the Mars Express orbiter. And they were using a device on it known as MARSIS, which is Mars Advanced Radar for Subsurface and Ionospheric Sounding, which is really, really cool. What they ended up doing was they beamed down radio waves, and when they bounce back typically from something like ice, generally it'll penetrate the ice a little bit and then it'll actually bounce back. But if there's something deeper than that, like for instance water, it actually will penetrate and then reflect back in like sharp transitions of the radio waves. So the radio waves will actually like have like a quick change.
Interesting.
Yeah, and so they picked that up, and so they realized that like at the time they thought maybe that this was an inconsistency, because every time there would be a flyby, sometimes that wouldn't be picked up. Sometimes like it would go away, and then sometimes they detect it again. So they actually thought that there was something going on with it. But what they found out was it was because the computers were actually trying to take an average of all the pixels that they were picking up. So they wanted to try and reduce the large data streams. So what they decided to try and do is they installed a memory chip to store the raw data files, and every time that they did this pass by, that's when every single time the signals were coming back, and they were able to confirm, okay, it looks like there's something that's underneath this ice, and it has to be some type of liquid water. But what they ended up doing was they did a few more aspects of research, because water is known for storing electrical energy better than rock or ice. So they actually were able to calculate the permittivity levels, which is just the capability of actually storing electrical energy. And they were able to actually measure not only the thickness of the ice, but they were able to pick up that there was actually a higher level of electrical energy stored where the South Pole, the polar ice cap in the South Pole, so right here is what you guys can see. it was much higher than elsewhere on Mars. So like this, obviously the permittivity levels, the electrical energy was coming back lower over the rock or over the ice, over the rock, but over certain parts of the ice, it was really, really high. So that means there has to be something underneath it as liquid water. So that was really interesting. They are not yet able to find out just how thick the water is, but right now they do feel that there is definitely a high concentration of salt, just because there has been a lot of salt being detected on Mars and in the soil. And also, the thing is, Mars is really, really cold, and for the ice to be able to melt, typically to actually obviously turn into liquid water, there has to be something else going on here. So what they obviously are assuming right now is that there has to be some type of really high sodium content in order to maintain it in a liquid form rather than it actually being frozen.
Right.
So that's what's really, really exciting right now, that they actually figured this out. But the only other thing though right now is that because of these high levels of sodium and really, really cold temperatures, that, I mean, it's literally below like dozens and dozens of degrees below zero, it's pretty unlikely that there might be microbes that exist there.
Sure.
So that's something I know that a lot of people are talking about, and they're like, oh, there's liquid water on Mars. Like, wait a second, maybe there's life. But because obviously the really high sodium content, and because it's really frigid water, there might not be a chance of microbes. But this was really, really exciting. Again, this was through the European Space Agency's Mars Express orbiter that ended up detecting this. So they're going to be doing a lot more research on this, and they're going to check actually the lower altitudes also on Mars, and if they're able to pick up something similar as far as like the radio wave signals bouncing back and possibly reflecting, then maybe, and then also it's warmer in those regions. So I've been reading that there's some consideration of, obviously if there would be something that would be like a microbe living in some type of water, might be in like that regions where it's a bit warmer, but it's still a pretty low chance, but it's still really, really exciting. The fact that there was actually like liquid water that was found. So
in any form. Yeah.
In any form at all, yeah.
We found a bunch of stuff. We found a bunch of stuff here on Earth in Lake Vostok, so I mean, there could be a possibility. This is a big deal, though. There's been lots of announcements of water on Mars over the years, but this is a lake. This is an underground lake. If this data is really true, and that might change the whole paradigm. For at least where we want to go next.
Yeah, it's fascinating.
Yeah, exactly.
Yeah, interesting.
Good point to bring up.
Yeah, very cool. Awesome. Yeah. So, Mr. Mike, you have labeled this section commercial crew hype.
Yeah. Are you excited? I'm excited.
Well, because with that term, it says to me like you're thinking like maybe it's like we're putting too much emphasis on it somehow or something. But like, but you're cold open. You were like really excited about it. So you mean hype in like the truest form, as opposed to not just like that's just a bunch of hype. You know what I'm saying? Like
if we're talking about hype as like a bad thing, then I'm definitely guilty of that type of hype.
Yeah, like my heart sunk for a second. All right, so what are we talking about then?
Well, there have been quite a few different updates recently with both Boeing and SpaceX. And I do have to get a little bit political here and talk about the Government Accountability Office's review, the annual review that they do for the Commercial Crew Program, and talk about kind of what the realistic situation that we're in right now. But even despite that, I'm still excited for what's going on. Let me explain what we're talking about. So first off, with Boeing, in June, Boeing discovered that there was actually a leak with the emergency escape motor that they were going to be doing a test of it this month in White Sands, New Mexico. And actually they found out that the leak wasn't necessarily with the motor itself, but actually with a valve on the test stand. So that should be something they should be able to easily fix and hopefully be able to pull off the pad abort test of the CST-100 vehicle really soon. And in really cool news, the Dragon V2 capsule has arrived at Cape Canaveral for processing for the demonstration mission 1, which is going to be the uncrewed flight test of the Dragon V2. And hopefully, they hope to reach readiness review by August 31st and be able to move forward with all the different processing so that that demonstration mission can happen by the end of this year. Now, when I'm talking about the Government Accountability Office, the report highlighted some realistic problems with both companies. Their biggest thing is that the average certification, where NASA is going to actually certify both of the vehicles to fly, is at the earliest would be December 2019 for Boeing in January 2020 for SpaceX, which is a bit surprising. And one of the big problems that the Government Accountability Office has noticed is that NASA still hasn't made realistic loss of life expectations. They have such a high level of safety assurance that they want the vehicles to be capable of that's far beyond any vehicles that NASA astronauts have ever rode on before. And it's unrealistic. And this was a problem that the Government Accountability Office pointed out last year and said that you guys need to not necessarily lower your standards, but have realistic standards, because if you keep this level of standard for safety, then neither of these vehicles are ever going to get to that point. And if they ever do, it's going to be such a huge amount of money put into them. Like it's just a huge compounded problem. So there's more delays to be expected, and this time NASA actually has agreed with a lot of the recommendations and is going to be putting out a report soon that will have the new way that they are evaluating all of the loss of life expectations, for how many missions could they successfully fly of these before they might have a fatal accident. However, one of the things that I'm really excited about that I've talked about on previous shows is that NASA has purchased seats that Boeing acquired on a Soyuz vehicle because Boeing had stake in the whole sea launch program that went bankrupt. And so instead of being able to get their money back, they made a deal with the company that bought Sea Launch and acquired 5 seats on the Soyuz vehicle. So NASA has purchased those flights that Boeing received, and they're going to be able to push access to the International Space Station to November of 2019, possibly as late as February of 2020. So as long as the vehicles are certified and flying by then we'll still have American access to the International Space Station until then. So I'm really excited. Both of these pieces of hardware are coming together. They're doing wind tunnel testing. I mean, just things are really coming together, and I am so excited. By this time next year, I feel like the reality that we've been hoping for is going to be true. And by the end of next year, I'm sure they're going to at least have the crewed test flights, if nothing else. So.
Yeah.
Oh boy, I'm really excited for this.
Yeah, that's really exciting. My understanding is that after the announcement of how the astronauts are going to be divvied up, the astronauts are going to be doing an AMA or an Ask Me Anything on Reddit afterwards, which is next week, I believe. So that's exciting. Can't wait to hear about that. I have so many questions. Oh, wait. Actually, I do actually have a few questions, but we'll get to that later. That's awesome. Thank you. Thank you, Mike. Yeah. And thank you for recapping all of the launches. I didn't thank you for that. I apologize. I didn't mean to.
A lot of launches.
Yeah, a lot.
That's why I'm here.
I appreciate that. Yeah. So, Miss Athena.
Yes.
Test be hunting.
Test be hunting.
Is that how I wrote it?
No, you said being. It begins hunting, but I was like, whatever. Tess be hunting. What's going on with Tess?
Yes, so Tess, which we're all super excited about. We spoke about it on a few episodes when it was being launched and then when it was being prepped. So the Transiting Exoplanet Survey satellite just began actually hunting for exoplanets. So this is super excited. It actually began on Wednesday, the 25th. So that was literally last week, when also I think that was the day that there was those 2 launches happening back to back.
It was a busy day.
Very, very busy Wednesday,
day.
Yeah. So it's really cool. Just for a recap for some of you guys, this picture right here, you could see the 4 cameras that Tess has, and those cameras are actually going to be viewing a large strip of the sky, and that's called the observation sector. And it watches for 27 days before it rotates to the next part of the sky. And in this diagram, you could actually see where it's going to be scanning. So it actually is going to be beginning in the southern the southern sky, and then it's going to move to the north part of the sky. So right now, it's actually looking further south, and it's actually going to be studying about 85% of the sky in total, which is pretty cool. It's 350 times more than what Kepler actually ended up doing. So it's literally surveying nearly the entire sky. So again, it just began its observations Wednesday, so that's really exciting. So since it did begin its observations Wednesday, that means we're going to be getting the data beamed back to us sometime around August. It'll be coming back to Earth. And every day after that, it's going to be periodically every 13.5 days. It'll be sending, obviously, its data back to us. And that's actually because its maneuvers, so this next image actually is going to be its orbit. So this right here is pretty cool. So it's going to be what you could see here, the acronym for PLEA and PLEP is Post-Lunar Encounter Apogee and then Post-Lunar Encounter Perigee. So it's going to be orbiting about every 13.7 days. And then it's going to be, obviously it's going to be crossing between like us and the moon. So it's going to be doing like a lunar passing orbit, and it's going to be catching a lot of the sky. So again, that's a 13.7 period, and then obviously we'll be getting that data back, which is really cool. So one of the main things that they are looking for is, I've mentioned before, is exoplanets. As also what's really cool is that there's obviously, the definition, by the way, for you guys who might not know what exoplanets are, there you go. It's a planet that's outside of our solar system. So there are planets that are found in other planetary systems out there. So it's searching specifically for outside of our solar system. So that's pretty cool. They have really high hopes, knowing that there literally are thousands of planets that are going to be able to be detected using something known as the transiting method. Which, by the way, the transiting method is just like detecting dips in brightness that are coming from stars. So it's a pretty cool diagram from NASA. So when you have, if you're able to see a star and you see a dip in its brightness, it generally is because there's a planet orbiting it or some type of object passing by. And it actually literally casts a shadow, causes it to dim, and we can actually detect that. And that usually means that there's some type of planet orbiting it. What's also really cool is that this is a huge collaborative effort. We have MIT, NASA Goddard Space Flight Center, Northrop Grumman, NASA Ames Research Center. There's like a whole bunch of other observatories worldwide that are collaborating on this. And one other exciting thing I was reading, actually on my way coming over here, is that Boston University is going to be analyzing about 50,000 red dwarfs. And by the way, red dwarfs make up about 70% of the stars in the Milky Way galaxy. And generally, they're too faint to actually see with the unaided eye, but they're extremely important when searching for exoplanets because they are, obviously they're lower mass, they're very cool, but planets can actually be located a lot closer to them and still be in the habitable zone. And that actually the habitable zone will be located closer to it because it is cooler. It's not emitting as much solar radiation. It's not as hot. So it's really, really exciting. A lot of exoplanets tend to be found around there. Like TRAPPIST-1 is orbiting a low mass star, which is really, really exciting. And we know how there were 7 Earth-like planets in that system. So so I'm really excited for this research, and I have our personal connections to brown dwarfs. So I'm really excited that there's 50,000 of them that are going to be analyzed through Boston University. Yeah. So again, I'm happy because we've been talking about tests for quite some time, and to know that the research just started on Wednesday of all days. I really think we're going to be getting quite a lot back, and then when James Webb launches, and then that's going to be that's going to be really working together right now, and that's going to be good. I think James Webb is still at down at Northrop Grumman at the current moment, but they're going to be working in collaboration, which is going to be super exciting.
Yay!
Yeah,
good. All right. Well, I'm assigning tests to you. You're going to keep us updated.
That sounds good.
And on red dwarfs.
That sounds great.
Is that cool?
That sounds
Nobody
good.
else gets to talk about it. Only Athena now. So that's it. Mike, what were you saying? I'm sorry.
I was just saying, based on how many exoplanets the last exoplanet hunter found, this one, and that was just looking at one constellation. This one, looking at the whole sky, is going to return so much. Oh my gosh!
Yeah,
it's going to be so overwhelming.
Perfect. Awesome.
It's going to be great.
Right. Well, that's what we've got going on for news. We're going to do a little bit of a commercial break, and when we come back, Mr. Jared is going to have a lovely interview with Bruce Bannard, the principal investigator for the InSight mission from JPL. Stay with us. We'll be right back.
Look into her face, determination in her eyes. She won't give up or quit or fall for little fashion lies. Filled with awesome expectation, this girl's a fascination. And nothing in her way will keep her from her destination. 'Cause she's fire walking, she's fire walking. When it's hot, she keeps on moving. Through the heat, keeps on improving. Yeah, she's fire walking. She's fire walking to be
All right. So before we get into our I almost said into our investigation. I guess that's about right. Anyway, I want to make sure I give a thank you again to our Escape Velocity patrons. These are the people who contribute $10 or more per episode, and also acknowledge our orbital citizens who present $5 or more per episode. They get access to our exclusive citizen-only hangouts as well. Like I said, we did one of those last week. We need to be doing more of those. They also get early access to After Dark as soon as it's available on demand. And like I said, while we're here, don't forget to hit subscribe on YouTube and hit the notification bell. Bing! So you know about future live shows if you're interested in any of these things and more. Head on over to patreon.com/TMRO. Mr. Jared, it's all yours.
All right. Thank you so much. And we're here at the Observation Lounge at Station 204. And as I said earlier, we've got Bruce Bannert, the principal investigator of Mars InSight. And we're always so excited to have people on the show, Bruce, especially folks that are that have stuff on the way to Mars. So thanks for stopping by.
Oh, it's my pleasure.
So first, just to kind of get started a little bit, tell us about yourself, because you're a principal investigator on a pretty important scientific mission to one of humanity's favorite planets, it seems. We keep chucking stuff at it. So tell us a little bit about yourself. How did you sort of get interested in space, and then how did you get to be a principal investigator?
Hold.
Oh, we're holding? Okay.
We're going to redo the second break.
Okay.
I made a big edit.
Bruce, we're going to redo this. We made a mistake, so.
Yeah, let's take it back
Yeah.
to break.
Okay, cool.
We're going to go all the way back to Carrie Ann's segment. We'll bring it back in from there.
Okay, sounds good. All right, so we're just going to, I don't know if you heard Ben, but we're just going to completely restart this segment. So, because I guess we had a, yeah, let's go back real quick.
Perfect.
I guess we had a little error. That's okay.
All right. Back to black and then on to me.
This is why you watch live.
Yep, perfect. Yep. All right. Now, before we get into our interview that Jared has, I want to make sure I give a huge acknowledgement to our Escape Velocity patrons. These are the people who've given us $10 or more per episode. And also, I want to acknowledge our orbital citizens. These are the people who've given us $5 or more per episode on Patreon. They, of course, get access to our exclusive citizen-only hangouts. Like I said, we did one of those last week. It was so much fun. You should really join us. They also get early access to our After Dark as soon as it's available on demand, and an early access to a view-only copy of the show rundown so you can see where all the chaos is coming from. And while you're here, don't forget to hit subscribe on YouTube and hit the notification button so you can know about future live shows happening. Oh my goodness, all of that and more. Head on over to patreon.com/TMRO. Mr. Jared, it is all yours.
Excellent. Thank you so much. And here we are on the Observation Lounge at Station 204. And I am so excited because we're going to be talking to Bruce Bannert, the principal investigator of NASA's InSight mission. And nothing gets me quite as excited as talking to people who have actual hardware on the way to Mars. And Bruce, thanks so much for stopping by the show.
Oh, it's my pleasure.
So, Bruce, just to kind of get this started, to let our viewers know a little bit about yourself, just tell us about yourself. How'd you get involved in science? Like, what got you started with that? And how did you get to be the principal investigator of NASA's InSight mission?
Well, I got started getting interested in space way back when I was in kindergarten. That was the time when the very first space launches were happening, when John Glenn went into orbit. And my mom tells me that I demanded to learn how to read so I could read the newspaper every morning to find out what was going on in the latest manned launch into space. And I sort of carried that through and decided to be a scientist and I actually didn't get into space science. I got into physics, but due to some fortunate meetings with people that had connections here and suggestions there, I ended up with a summer internship at JPL in the mid '70s, and I kind of grabbed onto that job and I never let go. And so I've been working at JPL ever since and studying Mars, Venus, the Galilean satellites, just about anything that spins around the sun. And so maybe back in the late 80s, early 90s, I got together with some guys at JPL who were working on sort of a really cool idea for a miniaturized seismometer that could go into space. And that got me interested in doing seismology. on Mars in particular, or we've actually looked at other planets too, but Mars is kind of the most interesting for a lot of reasons. And kind of kept on, putting together proposals to NASA and working with some of my colleagues, both in the U.S. and overseas. And finally, we hit pay dirt with the Discovery mission, Discovery program proposal for InSight back in 2010. And it's just really super excited to have the opportunity to do this really cool science at Mars.
Yeah, no, you're not actually the only principal investigator that we've actually had on this show this year. We had Dr. Alan Stern earlier this year talking about New Horizons. And I noticed both Alan Stern and you said that they started their missions, like the work to get their missions going in the late 80s and early 90s. Is it really like one of those things where it really does take a tremendous amount of time and effort in order to get your mission accepted?
Absolutely, because you think about it. How many cool things are there to do in space, and NASA has to pick, just a few of them that we can afford to do, at any given time. And so, for example, in the round of proposals that I proposed InSight into, there were 28 proposals, I think, and these were just to other planets, right? And that doesn't count the Sun and the Earth were considered planets, or so. 28 proposals, and if you look at the list of things that they were doing, going to Titan's oceans, to asteroids, comets, landers on Mars, balloons in the Venus atmosphere. Just so many cool things to do. So just the odds of actually, floating to the top of that, really competitive pile the odds are pretty long, and so I actually feel fortunate to actually have hit on this mission, even though obviously I think it's just about the coolest mission you can think of. But I know there's a lot of other cool missions out there, and it just takes a long time to refine your message, refine your science story, and to finally get everything lined up so that NASA feels like, let's go ahead and spend $500 million or $1 billion on this and see what happens.
Mm-hmm. And your role as a principal investigator on the mission, what does that entail?
Well, the principal investigator, the short version is that the principal investigator is responsible for delivering the science at the end of the mission. But in order to do that, you have to have the engineering lined up. You have to have the management right. You have to have the science team put together. You have to make sure that the instruments are working well. So the principal investigator is sort of like the CEO of the project. They're kind of responsible for just making sure that everything's working, that everything's lined up. And of course, I'm neither smart enough nor have enough hours in the day to do all that myself. And so I've got people who are in charge of the various different pieces. But at the end, I'm kind of supposed to be able to watch where all the strings are going and make sure that all the dishes are spinning on top of the rods and nothing's falling down.
Mm-hmm. And you've got quite the team based out of JPL as well, right?
Oh, we got the greatest team on the planet for exploring other planets, and we've got the management's work is done out of JPL. Our spacecraft is actually built by our partners at Lockheed Martin Space Systems, who also built the Phoenix spacecraft on which it's based, and we're really fortunate to have a great bunch of people out at Lockheed Martin designing and building our spacecraft, and now operating the spacecraft as it's on its way to Mars. And we've got a science team that stretches across the world. Both of our major instruments came from Europe. The seismometer is primarily built in France, with major components coming from the UK, from Switzerland, from Germany, and from the United States. And our heat flow probe was built by the German space agency, DLR, in Berlin and Bremen. And so we have certainly scientists on our team from those institutions, as well as others in Canada, Belgium, Italy, Spain. I'm sure I'm leaving some out. Poland. We've got investigators from all over the world. So this is really a really international mission. in a lot of ways, even though NASA is the host.
Yeah, you kind of touched on some of the instruments that you're carrying on board of InSight. Can you just kind of give us like an overview of InSight as a whole?
Okay, well, InSight is a geophysical mission that's designed to probe beneath the surface of Mars all the way down to its core. So we've sent lots of missions to Mars to map the surface, to look at the atmosphere, look at the interaction with the solar wind, et cetera. But we've never actually been able to concentrate on the inside of the planet. You know, once you get down below the top few kilometers that you can penetrate with radar waves, the deep part of the planet is pretty much a mystery. We don't know a lot about it. We know its total mass. We know more or less its moment of inertia. But in terms of what it's actually made out of, what its structure is, in terms of the thickness of its crust, the size of its core, that's all pretty much terra incognita, if you will. So InSight is going to use the methods that we use on the Earth to understand the deep interior of Mars and kind of complete our picture of the planet. And the most important one of those methods is seismology. So on the Earth, most of what we know about the deep inside of the Earth comes from seismology. And so seismology is the study of the waves from earthquakes that pass through the Earth. And so when an earthquake snaps the crust somewhere and shakes things up, it sends vibrational waves through the Earth. And those waves, as they go through the Earth, they're affected by the materials that they move through. And when they come up on the other side, you can measure the motions of the ground with the seismometer. And those motions, which you can see on seismograms as little wiggles, scientists have spent the last 125 years or so learning how to analyze those wiggles and just extract the information that's been stored in those waves as it goes through the Earth and figure out what the materials that it moved through, where there were changes from one kind of rock to another, for example, and be able to put together, once you've got waves that have gone through from many different earthquakes in many different locations, you can put together a sort of a 3D image of the inside of a planet. And so we'll be able to sort of image the size of the core, image the thickness of the crust, and be able to get some indication of the materials that they're made out of as well. And so this is going to give us a map of the inside of Mars for the very first time.
So I know that go ahead. Go ahead, Bruce.
No, go ahead.
I was gonna ask, because that map is, I would assume, generated by a network of seismometers here on the Earth. How are you going to make that map with just one seismometer on the surface of Mars?
Well, you got to get kind of clever. So if you have a whole network of seismometers, as you say, we have thousands of seismometers on the Earth, and we've got thousands of earthquakes that they measure every year. And so you can just load all that stuff into a supercomputer and crunch away and get your information. But if you only have one spacecraft and one seismometer, you just have to get a little bit clever. And there's lots of methods that actually only use one seismometer to get the same information. Maybe what our basic method is actually using the fact that Mars is smaller than the Earth, and so the waves can actually go farther, okay, relative to the size of the planet. And so if you have a Mars quake on one side of the planet, it actually sends waves that go through the planet, which are your PNS waves that you may have heard about in science class, but it also sends waves that go along the surface of the planet, surface waves, which are also called love waves or Rayleigh waves. And because those waves go on the surface, they can go from the Mars quake to the station, to your seismometer, and it also goes a long way around the planet from the Mars quake to the seismometer. And then the one that went the other way, it can go around again, and you sort of get multiple orbits around the planet of these surface waves. And so we can use these multiple arrivals to basically get more measurements, more information. And so we don't just have the P and the S arrivals as we often just use on terrestrial seismology. We also have multiple surface waves arrivals. And so we have, 5 or 6 different measured arrival times, and we're able to use that to get the sort of the 3-dimensional location of the Mars quake plus its timing. And that's what the basic sort of data point that you need to start your seismic investigation.
That is an incredibly clever way to do it. That is so cool. Now, in our chat room, St. Alex is asking a pretty good question that I was going to ask, which is, will the detector be sensitive enough to tell the difference between a potential Mars quake and a potential meteorite strike?
Yeah, it turns out that both of those phenomena make seismic waves, and if you look at it just really quickly, they look pretty much the same. You get a P wave and an S wave, and then it dies out. But if you go into detail and you analyze the spectrum of the signal, the amount of energy that's coming through at different frequencies, the frequency content of a quake is different than the frequency content of an impact, and also the partitioning of energy between the P waves and the S waves. When you have an impact, most of the energy goes into compression as it bangs into the surface, whereas in a Mars quake, most of the energy actually starts off in shear as the fault, shears the planet. And so by looking at the details of where the vibrational energy is stored, which kinds of waves it's stored in, and what frequencies, we can actually tell the difference between a Mars quake and a Mars impact.
And just to kind of follow up with a little bit of a question here, I'm going to kind of combine two questions that we got. One from Dutta, which is asking how much more sensitive can you make your instruments? So just kind of overall, how sensitive is the seismograph? And then another from our chat room, from Henny's Vorwerp, which is how much easier is it to get fine details from seismology on a planet without humans stomping around on it, or does that not matter? So I guess how sensitive is your seismometer you're putting on the surface of Mars, and does the fact that there's no human activity sort of enhance that?
Okay, so in numbers, the sensitivity of our seismometer, sort of the maximum sensitivity is about 10 to the minus, or 5 times 10 to the minus 11 meters per second squared. Okay, and that doesn't really mean much, but if you think in terms of being able to visualize it, you think about the size of a hydrogen atom, sort of the Bohr radius of a hydrogen atom, the sensitivity is about 1/4 that radius, okay? And I'm not talking diameter, I'm talking radius. So that's really, really small. And those are the size of the vibrations that we're picking up on the surface of Mars. So as you can imagine, that makes it very sensitive to quake signals, but it also makes it really sensitive to almost everything else in the universe as well. I mean, we pick up magnetic field variations, we pick up temperature variations. Of course, as the wind's blowing, that's going to move things around. And so we actually have to have a pretty sensitive environmental monitoring station on the spacecraft as well, which means we have a weather station which measures pressure, temperature, and wind. We have a magnetometer which is measuring not only the dipole magnetic field of the planet, which is kind of a cool thing to be looking at, but also variations of the magnetic field due to ionospheric currents and so forth. So we can then pull a lot of that noise out of our seismometer record and get down very, very low in terms of seismic noise level. And on the Earth, as your listeners point out, we get a lot of noise on the Earth. A lot of it comes from human activity. There's ways of kind of getting away from that. You can put seismometers, out in the countryside. You can put it down in mines and get away from a lot of the what we call cultural noise. But what you can't get away from, it turns out, is the ocean. And the ocean is always, lapping onto the edges of the continents, and that motion from the ocean you can pick up anywhere in the world, and that's sort of the limiting noise for seismology on the Earth. We went and did our testing in a place called the Black Forest Observatory, which is an old silver mine in the Black Forest in southern Germany, and it's the lowest noise place on the planet. But even there, it's the sound of the ocean, hitting the shores of Norway just comes booming right through. And so the absence of an ocean on Mars is really the thing that really helps us out a lot, and it pushes the noise down by a factor of between 10 and 50 relative to the Earth.
I would have never even thought about waves hitting the continents doing that, but that makes complete and total sense. So also going to our chat room, Jasper has a great question, which I was going to ask too, which is, what's the current geophysical model for Mars? You heard that the core is actually liquid throughout due to a high sulfur content. I guess, what is the current model, or do we not know, and that's why InSight's going there?
Oh, well, how do I say this? There are many, many current geophysical models of Mars. I mean, the less data you have, the more models you can imagine, and there are a lot of models imagined for Mars. One set of those models includes a liquid core, and we actually have some evidence that there is a liquid core on Mars from the measurement of the gravity field by orbiting spacecrafts and looking at the variation of that gravity field, and really that means the sort of the reorientation of it over time. And by looking at the spin of Mars and the wobble of that spin, it's just kind of right at the edge of our error bars. It looks like there's a liquid core that's sloshing around inside the planet. And of course, the idea of sulfur is an interesting one, because if it was a solid iron core, I mean a pure iron core, it would almost certainly be solid by this time, because all of our models for how Mars might have cooled off, it's very difficult to figure out how you could keep the interior hot enough to keep a pure iron core liquid at the current date. But if you mix a little bit of sulfur in there, that actually lowers the melting temperature, just like for when you put salt on a sidewalk, and it lowers the melting temperature of the ice and allows the water to the ice to melt, even though the air is technically freezing. And so you can actually unfreeze the core by mixing in a little bit of sulfur or carbon or oxygen. There's a lot of elements that you can mix in. Sulfur is probably the most likely one. And so sort of the kind of the favorites of the Mars geophysical models, you know, the ones that sort of have maybe the most followers, tend to have cores with some sulfur in them and that are molten.
So you guys started, when did you start building the NASA, or when did you start building InSight?
Well, we got selected to go into our building phase in 2012. So we've been sort of putting the nuts and bolts together for the last 6 years. We actually had the spacecraft completely ready to launch in 2016, 2 years ago. That was our original launch date, and we had everything ready to go except for one thing, and that was kind of an important thing. That was our seismometer, and it turned out at the very last minute, just about a month before we were supposed to deliver the seismometer to be integrated on the spacecraft, we found with our testing data that it developed a little bit of a leak in its vacuum system. There's a vacuum container, a more or less spherical container that contains the 3 seismometers, the 3 long period seismometers. You can see it in this picture. It's the gold sphere there, and there's a very hard vacuum in there that allows the seismometers to move without any air resistance. They have some very sensitive capacitive sensors, and if you get any gases between the plates of those sensors, it damps out the motion and makes the seismometers much less sensitive. And so, unfortunately, you can't just take this sphere and weld it shut and then be done with it. You have to take all the wires that take the power into the seismometers and bring the signals out. They have to go through that enclosure, and the feed throughs that we had to do that. One of them started leaking just a little bit, and I figured out that the size of the leak in terms that people understand is that if you had the same leak on the tire of your car, you'd lose about 1 psi of pressure after 50 years. So, but for the seismometer, that was enough to just basically kill the sensitivity, and it would not have been worth flying this thing to Mars. And so we tried to do a quick fix on it, where we put some basically stuck some glue on the top of it and tried to plug the leak that way. But because the seismometers have to experience temperatures of temperature variations of 50 to 80 degrees over the course of the day and of course of the year, the thermal expansion and contraction of the material was such that the leak kept on opening, and so we had to stop the launch. We went to NASA and basically begged them to give us a second chance and to fund us for an extension of our mission. You probably know that to go to Mars, you only have the planets lining up properly every 26 months. And so it was, if you can't make your launch, you have to wait 2 more years. And so NASA decided that the scientific value of our mission was great enough, and that our plans for recovering from this problem were solid enough that they gave us the go-ahead, and we redesigned the enclosure for the seismometers, got different kinds of feed-throughs that were more reliable, and tested the bejesus out of it. And finally, we're confident that we've got that problem behind us, and we're able to launch it last May.
Yeah, and to kind of continue on that from our Twitch chat, Toka is asking, other than obviously fixing the seismometer, what was the biggest advantage gained by the 2-year launch delay? Did you guys do anything else other than just making sure the seismometer is actually going to do what it needs to do on Mars during that launch delay?
Well, space missions, you never have enough time to do everything that you'd like to do, and given 2 more years, I would not have asked for 2 more years. I wanted to launch in 2016, but given 2 more years, it did allow us to go back and solidify a lot of the things that were good enough, but we could make a little bit better. It allowed our operations team a little bit more time to sort of develop the operations architecture and test a lot of the procedures a little bit better. So we were able to do a lot more testing. We were able to refine a lot of our operations concepts. Mostly technically with the spacecraft, it was pretty much ready to go, and we didn't mess with it very much. There was a few things that we changed out. Every once in a while, there's a spacecraft in orbit that has some part on it that fails, and then you go back and say, oh, we've got those parts in our spacecraft as well, and you can go back and kind of trade those out for something that is a little bit more robust. And so we were able to tweak a lot of things and make it a little bit more robust. And it turns out that the 2018 opportunity to get to Mars turns out it's a lot easier to get to Mars in 2018 than it was in 2016. And so that gives us a little bit more margin of safety when we actually get to our entry, descent, and landing phase.
And before you do entry, descent, and landing, you got to get through launching off of this planet and getting out of our gravity well and heading off to Mars. And that happened back on May 5th of this year. What was launch day like for you as the principal investigator?
Well, launch day for me, first of all, launch day lasted about 48 hours for me, because we launched at 4 o'clock in the morning. And I was up, really early the morning before, talking to reporters and, going through the final, checkout lists. And so that was a very, very long day. But I think I was walking about 2 feet off the ground the entire time. It was just so exciting and so incredible, after, watching, the astronauts, the first Mercury astronauts, launching back when I was, 4, 5, 6 years old, and then to actually have a rocket with my hardware sitting on top of it, only I think I was about 3 miles away from the launch site that morning, and to just hear that rocket going off and knowing that my stuff was on there is just it's indescribable. It really is. But I've never been more excited in my life, except maybe when my kids were born. It's that kind of emotional experience for me.
Yeah, and we hear, we've talked to a lot of folks who've worked on different missions, and they kind of talk about feeling like their craft that they're working on is like one of their children. Do you feel that way about InSight? Like it's your child heading off to college, if you will, to do some work on Mars? Yeah,
it really does. I mean, I've been involved pretty closely involved in the design and the manufacture of the spacecraft, and especially the payload, the instruments. And I really do feel like these are like my kids that are going off. And somebody asked me whether I felt like I didn't want it to go away. I wanted to hold on to it, and I felt like no, absolutely not. I mean, that's what it's supposed to do. That's where it's supposed to go, and that's and I get to go along with it. And so I was happy for it to go. It's hard to let go, but it's also incredibly cool to have it heading off to Mars.
And you also had two little passengers on your way with you, Mars Cube 1, or what I understand is pronounced Marco A and Marco B.
Yeah, absolutely. That's a really cool set of spacecraft. These are actually technology demonstration spacecrafts. These are the first CubeSats to leave Earth orbit and travel to another planet. And CubeSats are sort of a different way of approaching space. So the InSight mission is if you put together all the different pieces that have been done all over the world and all the time that's put into it and all the operations, it's going to be pushing close to $1 billion by the time we're done. And the Marcos were put together for some small number of tens of millions of dollars, and sort of just a few engineers and some students kind of working in a small lab. And so it's really kind of a really personal way of exploring space. And these Marcos, they're going all the way to Mars, just in formation with InSight. And if they make it to Mars, which is not a sure bet because it's a low budget operation, they're going to actually be able to relay the signal that InSight is transmitting as it goes through the EDL process, the entry, descent, and landing process. We don't have any way else of getting sort of a live feed from Mars. Most of the data is going to be transmitted and received by the Mars Reconnaissance Orbiter, but it'll be recording the data and then playing it back 3 or 4 hours later. So Marco actually gives us an opportunity to see what's happening on the InSight spacecraft as it's descending into the Martian atmosphere, which is going to be really cool on landing day.
Yeah, and some folks were in our chat room were asking if there are nicknames for the two CubeSats, and I believe the engineers at JPL named them Wally and Ava after the two characters from the movie Wall-E. So
that's right.
So
that's right.
That's pretty cute that they did that. So InSight is on cruise right now to Mars. It's just doing that energy that was released during the launch. It's still moving it forward towards Mars. And what do you do during the cruise portion on your way to Mars?
Well, actually, today, just right when about the time that this show started, we executed our what we call TCM2, which is our second trajectory correction maneuver. And so as we go to Mars, we got the big boost from that Centaur upper stage on the Atlas IV, but then we have to kind of tweak that trajectory so that we hit our entry corridor really precisely when we get to Mars. And in fact, the Centaur actually gets us on a trajectory that's going to miss Mars because we don't want the Centaur to hit Mars because it's not sterilized. We don't want to contaminate Mars with any microbes that might go along with it. So we did our first trajectory correction maneuver to bring the trajectory into one that's close to Mars, very, very, very close to Mars. And then just today we did our second maneuver, which actually for the first time targeted our entry corridor right at the edge of Mars. And so I was actually watching that on my iPhone as you guys are going through the first part of your show and looking at the Doppler residuals, the tracking of the spacecraft. It looks like InSight nailed the TCM2 right on the button. So right now, InSight is actually on its way to actually land on Mars for the first time, and we have about 3 more opportunities to further refine that pointing as we get closer to Mars. And so part of what we're doing during this cruise phase, which lasts about 6.5 months, is refining that trajectory so that when we hit Mars, we're hitting it at exactly the right place to land properly. We also have some engineering checkouts where we look at the various subsystems on the spacecraft. We've powered up all of our instruments to ensure that they've survived the shaking and the high G loads from launch, and they've all checked out perfectly. And so at this point, most of what we're doing is just monitoring the spacecraft, making sure that it stays healthy, and we're doing practices. We're practicing our entry, descent, and landing process. We're practicing our first few sols on the Martian surface, and we're practicing some of our deployment operations, which is really critical for our particular payload. The seismometer and the heat flow probe are bolted to the top of the spacecraft deck, but of course what we want to measure is what's going on the ground, and so we have a robotic arm that picks them up off the deck and puts them on the ground, and that whole process takes about 2 months between characterizing the area in front of the spacecraft and putting together the sequences for that robotic arm to pick up the various different pieces and put them down on the surface. So we're going through a lot of practices of those using our spare spacecraft that's in what we call the sandbox at JPL.
Yeah, and just kind of letting our viewers know that the animation we're showing here of the vehicle landing on Mars is actually from Phoenix landing on Mars, which I believe the entry, descent, and landing is going to be very similar to Phoenix.
It should be identical to Phoenix. I mean, we have the entry, descent, and landing system is a really difficult entry, descent, and landing is a hard thing to do at Mars. Phoenix did it perfectly, and so we just didn't want to change anything that we didn't have to. So that part of it is really close to Phoenix.
And can you tell us a little bit about the heat flow probe? Because we do have some footage actually of showing it being undergoing testing in the laboratory. What exactly is a heat flow probe, and what is it going to do for this mission?
Well, the heat flow probe is actually going to measure the amount of energy sort of coming up from the interior of Mars, all the way up from the core and the mantle, and that tells us a lot about the dynamics of the planet, the sort of the geological engine, the part of the planet that powers mountain building, volcanism, tectonics, and so forth. And the way you measure that is you actually look at the increase in temperature with depth. And so we have a device that's we call it a mole. It's about 18 inches long, and it has inside it has a hammer which knocks it down just a few millimeters at a time, and it digs down about 15 feet, about 5 meters below the surface of Mars. And you can see this ribbon cable that's attached to the back of it. And the ribbon cable has the leads in it for the power and the signal leads that go back and forth between the spacecraft and the hole, but it also contains little thermocouples every foot and a half or so we can measure the change in temperature as we go down those 5 meters. And if you've ever gone down into a deep mine, you'll find that it gets warmer and warmer as you go down into the mine. And we use that phenomenon to be able to measure. It's only maybe a tenth of a degree or less as you go from the surface down to 15 feet, but we measure that very precisely, and we can extrapolate that temperature increase down to the interior of the planet and look at the amount of energy that's coming up out of the planet at the InSight landing site. And so after we get the heat flow probe deployed to the surface with our robotic arm, it still has to drill itself down about another 15 feet below the surface. And so that's going to take it takes about another 2 months or so, because we go down a few feet and stop and measure the properties of the soil every few feet. So that takes a while to do all the science on the way down. But once we're down there, we'll be measuring basically the heat that left the core maybe 2 billion years ago.
And from our YouTube chat room, Mike Hatfield asked a question that I'm going to combine with some other questions I've seen from folks in our chat room earlier, which is that will InSight be able to detect underground aquifers? And also, with the news about finding liquid water in or the potential for liquid water in that lake in the higher latitudes on Mars, if you guys run into ice, subsurface ice or anything on the way down, are you going to be able to tell that that's what that is?
Well, we really don't expect to run into ice at this latitude. We're landing right about on the equator, just a few degrees north of the equator, and the surface temperatures are relatively warm for Mars. And so between the sun heating the surface and the heat coming up from the interior, it's not likely to find ice below the surface at those latitudes. You get up about 30 degrees north or south, then you can start running into ice, at least from our theoretical calculations. We also have impact craters in the general area that don't show any excavation of ice. So ice in our area is not expected. There could be an aquifer in our area, and if there was an aquifer at depth, it's possible to be able to detect that seismically. It's a really subtle signal, a subtle effect on the seismic signal. We'll be looking at it and trying to tease that out of the data, but we can't guarantee that we'll be able to see that. It's something we'll be looking for, but it's right at what we think the edge of our detectability is. What we can say about the detection or the apparent detection of this lake beneath the polar ice cap is that by looking at the amount of heat coming up from the surface, we'll be able to better understand what the temperature at the base of that ice cap might be, and that could help constrain, the possibility of water or salty, water existing at those kinds of depths on Mars. And so our heat flow probe might give a little bit of information that's relevant to that. But we'll have to wait and see what we discover. This really is a mission of discovery because none of these measurements have ever been done before on Mars. And so any information we get will be the first information of its kind and will probably revolutionize, what we think about Mars.
And how long is InSight supposed to operate on the surface of Mars?
Well, we've designed the mission to last one Mars year, so a full seasonal cycle on Mars. So we land near the beginning of Martian autumn or Martian fall, and so we're going into a Martian winter. We've sized our solar panels and our insulation and heaters to be able to survive a Martian winter. So once we get through that, we get through the Martian summer, which is relatively benign environment for us, and so. One Martian year is our prime mission. So by the end of one Martian year, we should have enough seismic data to at least get first measurements of the various different quantities we're looking at, like the crustal thickness, the size of the core, and the composition of the interior. But once we get to the end of our prime mission, we don't have anything that we use up. We don't have fuel or any other kind of consumables. And barring any kind of failure of electronics or something like that, there's nothing to keep the spacecraft from operating even longer. And so we'll be proposing to NASA, I'm sure at the 2-year mark, to allow us the funding to operate the spacecraft longer, because the more Marsquakes that we can accumulate, the longer that we can measure the temperatures at the subsurface, the more accurate our measurements become. It's really a statistical thing, and so we can really start to hone in on the real details of the Martian interior the longer we're there on the surface.
So basically, as long as you can.
As long as we can, as long as they give us money to talk to the spacecraft.
Yeah. All right, Dr. Bruce Banner, thank you so much for coming on tomorrow today, and we definitely look forward to landing. What day? When is InSight landing on Mars so we can all tune in?
It's landing on November 26th, which turns out to be Cyber Monday, the Monday after Thanksgiving. And so, as you're sitting there on your doing your shopping online, you can keep a window open on one side of your screen and watch our entry, descent, and landing, which happens just before noon, I think, Pacific time on the 26th of November.
Oh, excellent. So we can, I'll just have some coffee and get up and watch it. So.
Absolutely.
Sounds great. All right. Thanks so much for coming on the show today. Now, we are going to head to...
Oh, it's been my pleasure.
Thank you, Bruce. So we're going to head to our next segment where we've got your comments from last week's show. So stay tuned. There's more tomorrow right after this.
It both draws us together and tears us apart, brings discoveries to cure us and threaten us. It is neither good nor evil. It is what we decide to make of it. There is so much more to learn, and we are curious. Together, let's explore the science of tomorrow.
Try not like.
We did not fail.
No.
We're still going.
Still can't hear Mike.
You can pantomime.
Hi, welcome back,
There
everybody.
we go.
Hey, everybody.
Much better.
Sorry, my bad.
It's okay. Lisa didn't ask you anything. Am I on? I am not on.
Okay, so
Now I am
shared
on.
carrier
Yay.
over here. That is right here.
Yep. La 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 la. Okay. So close. Wow, is that really dark or is it just me? Actually, they're all dark, but I guess that's consistent, so I'm not going to worry about it. Okay. Thanks for that, Dada.
Marty the Martian. Martians tapping the ground with tiny.
You guys ready?
Yep.
Sure.
Yes.
Rock and roll.
That was a great interview. But before we get into our questions, comments, concerns, and complaints about our last show, I want to make sure I acknowledge all of our patrons. These are the Escape Velocity citizens who give us $10 or more per episode on Patreon. Then there's the Orbital citizens who are $5 or more per episode on Patreon. And then our Suborbital citizens at $2.50 an episode on Patreon access. They get access to our exclusive citizen-only hangouts. They also get early access to After Dark as soon as it's available on demand, and free U.S. shipping on the TMRO swag store. So those are the patrons. Actually, there are some more patrons that we like to thank at the end of the show as well. So stay tuned for that. If you have not seen your name yet in the show, head on over to patreon.com/TMRO. Okay, on the last show, we were talking about, we did a round table, or a half round table, as some people like to point out. What are the missing pieces needed?
Semicircle table.
There you go. What are the missing pieces needed to get humans to Mars? So, which was a very fun, energetic, and lively conversation, if you joined us for that. The first comment actually comes off of our community.tmro.tv. If you have not joined us, please do. There is
Join us.
so much going on over there right now.
It's really cool.
It is the brand new forums, and there's just, you name it, we're talking about it, and it's been really, really great. A lot of really great contributors, and like this particular comment. This one comes from UT Lurker, who identifies as a suborbital citizen. Says, a good discussion. I think I agree that radiation and health in general are the biggest issues. I also think that as long as those people who sign up to go are fully aware of the risks, we shouldn't have to wait until every possible aspect is perfectly safe before we go. If we did, we would never go. I only hope that when someone dies, and notice I said when and not if, we don't just panic and pull the plug. As long as we learn from it and improve, we should carry on. Yeah. It's normally we go for these comments so we can have a little bit of conversation. I doubt that there's a single person here who's going to go, yeah, no, that's not what I think at all. I feel like this is like our deepest motivation in general.
Yeah.
I wholeheartely
Since I
agree.
wasn't here for the round table, let me weigh in on this, if I may. I mean, with the whole risk and everything like that, I mean, it's going to be pretty well understood, and we're not going to be able to have a vehicle that's 100% safe. But I mean, I believe that still to this day, I know back in like the Apollo days, all the astronauts had to sign waivers. I mean, they knew how dangerous those vehicles were and that they could lose their lives on it. And I think that the same thing is going to be true of the first Mars missions, or even after we're doing it for a while. Before they're 100% safe, people are going to accept that risk, and it's going to be part of the whole equation. That's what I think, anyway.
Yeah, and I was kind of talking with a friend of mine about the concept of acceptable risk and things like that. And I feel like if you are an astronaut and you're going on a Mars mission, you have signed up for, and you are well aware of the risks that you're taking. And these are people who are aware of the risks that they're taking. It doesn't mean that we shouldn't cast asunder safety and basically say, oh, well, who cares about safety? These people know that they could potentially die, so we don't need to handle that at all. But we should definitely do everything we can to try to minimize, the problems with that. But actually, I was going to say, Dutta has a really great, great summation of this here. So I guess I'll read it for Dutta. Or Dutta, do you want to read it yourself? So okay, I'll read it for Dutta. It says, it's not difficult to find comments from Grissom, White, and Chaffee, the three astronauts who lost their lives on Apollo 1, from before the Apollo fire, that they understand the risks associated with their jobs, and they have expressed that if they should die, that they would want their cohorts to carry on with the mission because they thought it was worth the risk.
Yeah, I think that's precisely the point there. Is that it's not just to be the first human on Mars. It's not just to be the new Watney, as it were. It's to make sure that we get there and we continue to be there and furthering humanity.
And everybody, I always say that spaceflight needs to be safe in order for it to occur, and everybody always assumes that I want 0% risk involved in spaceflight. But I understand that there's no way to get rid of 0% risk to begin with, because after all, breathing is what gets us all done, right? I mean, we're taking a risk in every single thing that we're doing. It's just that we should do as much as we can to minimize as much as we can with that risk. You do that when you design aircraft. Like you have the ability to operate an airplane with just one engine. And they did that with Falcon 9. There's 9 engines. If one goes out, the others can keep up, and that's actually been flight proven that you can do that with their first operational mission to the space station. So I'm not saying. I think a lot of people misinterpret. Folks like me who are very big on safety, we're not saying don't ever do it. We're just saying that we should try to make it as safe as we can. But also, we're riding explosions on top of fuel tanks, so we're not trying to kid ourselves here about the fact that what we're doing is unbelievably unsafe. So, it's kind of like race cars. You build race cars to try to be as safe as possible. People are going to die in crashes in race cars, but you do everything you can to try to mitigate that from occurring. It will happen at some point in the future, but you try to do everything you can to make sure that it doesn't.
And and him saying too, like waiting for the right moment, sometimes you'll never actually take action. And it's such a coincidence, but a friend of mine just gave me a quote yesterday about this concept from, I don't know if any of you guys read Paulo Coelho's books. Like he wrote The Alchemist. There's this book called Warrior of Light, and this quote I want to share with you guys. It says, if he waits for the ideal moment, he will never set off. The warrior requires a touch of madness to take the next step. I literally saw that like last night before I went to sleep, and so this comment is just so right, because that's what it is about space travel and space exploration, is that yes, we can plan for safety as much as we can, but if you keep waiting and waiting and waiting for everything to just line up, you're never going to get it done. You just need that little touch of madness to just say, let's go, let's do it. So I like that they, thank you for bringing that up, UT Lurker.
Go ahead, Mike, you're saying.
Just like the commercial crew story that I was talking about earlier. I mean, the standards that they're holding it to is, it's a really, really high standard. And the big complaint has been, if you held it to the same standards that you held the space shuttle to, then we could authorize both of these vehicles today. So we need to have like a more like acceptable level of risk for this, because it's falling into this whole category here. It's just like, this is an unrealistic expectation, and we're not going to ever get to this point.
Well, I feel like with the space shuttle, you saw what happened after the Challenger and Columbia accidents, right? I mean, a lot of people don't know this, but the first year after Challenger, there was zero gung-ho attitude about shuttle in Congress. Pretty much all of Congress wanted shuttle shut down entirely. Like, that's the end of the program. You people can't manage this correctly. You're toast. You are not allowed to do this anymore. And the same thing happened after Columbia as well, when they looked at the engineering mismanagement and other things like that. There was a large number of people who said to shut it down. So I think the increase of those standards is NASA reflecting on that and basically saying that we really don't want this kind of a situation to happen again, because, you know, it just doesn't end well when you end up having people dying on vehicles, especially if you're a commercial company. That's not going to work out all that well. If you guys want a really
that would really be the end of a commercial.
If you want a really great example of a commercial company not having a great safety record on something and not doing so great on that, look up the DC-10, the airliner in its early days.
Yeah.
Not particularly safe, both from some of the design faults that were not found out in testing with it, and also some of the operational things that airlines were doing at that time, but it still pretty much killed the DC-10 at that time. So that's usually my go-to when I tell people, you know, if you really want to know what happens when you don't really take safety too seriously, or you don't put safety through as thorough a test as you can, look at the DC-10, look at how quickly the orders for those airplanes dropped when they started having all those accidents in the 70s. So.
Wow.
All right. Great. Good discussion, guys.
Really good.
Next comment also comes from our community.tmro.tv. Comes from Fit Orion. Says, to me, the biggest hurdle which needs to have real work and real hardware created and tested is in situ resource utilization. For short-term missions and long, it's very important. We need to be able to live off the land. For short-term, fuel. Maybe some water and oxygen to breathe. Farming. Consumables that we really, really don't want to have to haul all the way from Earth. And then for long term, we need to jumpstart industry. We need to mine, process, and then build not just structures, but technology. We'll need circuit boards, resistors, capacitors, processors, all the things that make the ships, suits, habitats are made of.
Yeah.
Wow.
Yeah. Who wants to go first?
I'll go first. I'll just say Mars 2020 has a instrument on board that's going to carry to Mars called MOXIE, which stands for Mars Oxygen In Situ Resource Utilization Experiment, and they're actually going to take in the atmosphere of Mars and try to generate oxygen with it. So the in situ resource utilization, which I agree, that is like a huge factor in having a successful crewed mission on the surface of Mars.
Yeah.
That is definitely going to be initially demonstrated within 5 years, so which is very exciting.
Yeah.
So,
wow, I actually didn't know that.
and it's not just being demonstrated here; it's being demonstrated in the environment that it should happen in.
Yeah, it's beautiful.
So, holy moly!
And that's at least one aspect of that. That's at least one aspect of it. And of course, this is all regarding, you know, colonization and actually setting up a real presence there. I mean, just for the initial trips, you know, the NASA or international-led trips to get there, excuse me, I feel like the biggest hurdle still is a lot of the biomedical research and the things that we're going to need to have so that astronauts and cosmonauts and whoever are able to survive the trip there and back. You know, are they going to be able to survive, you know, a 4 to 5 year trip? You know, it's shorter or longer depending on what the mission architecture is. And so all of these different things, especially with the ISRO stuff, that's one aspect of it is converting, you know, the atmosphere. But, you know, what are we able to make out of the soil? You know, are we able to access, you know, a lot of the different methane and can convert that? You know, what can we use electrolysis to melt some of the water ice that's there? You know, do we even bother? You know, so there's lots of questions to this, and I feel like we're at least researching a lot of these basic questions. There's a lot of research going on with the biomedical questions for the whole lunar orbiting platform to answer those questions and make sure, you know, do we need some sort of artificial gravity with like a spinning centrifuge or something like that, just so that, you know, they can survive 4 years in space or something like that as a maximum. So lots of things are being studied, and I feel like they're all being worked on, at least in some way.
Has there been any industry that's started yet, like here on Earth, that will possibly be used for over on Mars? Because I know that is something that really is important, that needs to be started first here, I believe. Like, if we are going to be colonizing, well, we will be. Any industry that's going to exist on Mars, I think personally should be started here. I don't think it should wait until people get there to then figure it out. I don't know what you guys think as far as that. I know we have to get to Mars and we should do it, but I think that any type of industry that we're thinking of, whether it is like
obviously going to be mining, or it's going to be like building possibly a factory to do this process, to actually be converting any of the elements that are found there. I think that the industry needs to be started here on Earth first, be created, and then obviously be transferred over to Mars.
Yeah.
Do you guys know of anything that started?
No, I'm not sure exactly. Maybe Made in Space, which is the company here that does the printing on the space station.
They're definitely looking at stuff for manufacturing. Yeah.
Yeah.
Okay.
And I kind of want to add a little bit to what you said. I feel like maybe 2 or 3 launch windows before we send a crew, we should send the industry that can actually be done robotically, so that all of this can be set up so that when the crew lands on Mars, they have the minimal amount of setup that they actually have to do.
That would be good too.
That way, if there really are any actual ill health effects that we haven't accounted for, those can be handled, and they still have kind of like something to...
Base camp kind of
they
set
have
up by the robots.
Base camp's already set up. It may not be comfortable, but you're going to be alive at least for the time you need to recover.
Yeah.
So
yeah, that definitely
one company that I know of is called Paragon. I believe it's Paragon Space Development.
Yes.
And one of their areas of expertise is life support. So one of the big things they're all about is, water recycling. And of course, they're looking at some of the different studies too of like what resources could we utilize there, and can we convert that into, survivables, consumables, the things we need to survive. That's what the industry is going to be on Mars for a long time, is just being able to survive.
Yes.
Yeah.
Yes.
Cool.
At least that company that I...
Yeah. No, that's great. Somebody in the chat room said Boring Company, Made in Space, of course, was mentioned. There's definitely a couple of things, but it's a good point.
I do know individual people that are working on it too. Like I know mentioned Kay McCoy in the chat room, Phil Metzger, who's got a really cool Twitter feed if you want to know all about asteroid and Martian mining and development from resources with that as well. So
totally.
Yeah.
Awesome. Last comment here comes from Kev G off of YouTube. When you consider all the problems associated with a mission to Mars, why go there? I mean, the only reason to go there is to confirm the existence of life. What other reason is there? The money will be better spent on sending probes to Europa and Enceladus. I'm sure somebody at this table and virtually at this table has something to say about that. Who wants to go first? I mean, you both literally were like, well. I'm sure you didn't actually flip the table on that one.
That would have been great. I think if the hologram flipped the table, that would have been very entertaining. I mean, I think that obviously, we should...
emitter back. Jeez.
What? Wait, I totally missed that.
Give me the emitter back.
Right, there you go. I think you were going to say something.
Yeah,
go ahead.
I mean, of course, we should go to multiple places. We should explore multiple places. But why Mars? Mars has been our focal point for a very long time. I think that, of course, we should also do other locations, other places, but specifically Europa and Enceladus, those two are obviously extremely important, at least in my opinion, to be visiting and to really explore. But Mars is just something that we have been looking at for a long time. We are making so many discoveries on there. We are finding out so many more things. And the fact that it really was so similar to Earth, like a long time ago before it got really, really cold, I think that there's just so many answers that can be found there. And I think, again, it is our neighbor. It is the first step to becoming, taking that stepping stone and exploring outside of the house, outside of your city, outside of your state, outside of your country, and expanding. And I think that that's exactly what it is. And, we can jump somewhere else for sure, and we're going to do that. But I think that the first step is Mars. And it's not that we're not throwing money at it. I think that it's because every time we put money into space, it is, being retrieved back to us here on Earth from discoveries made. And also, too, it's like, we can keep living, but we still don't exactly know what our purpose is. And I think that the more that we start to explore and we start to expand, we will find that. And otherwise, if we just sit around and hang out on this rock all the time, what else are we going to do? Of course, explore our oceans, live life. But that's part of exploring. So, I mean, that's my own personal opinion. I think that this is a great point to bring up, and it's a great debate because a lot of people ask these questions. But again, it's do you want to just sit in a cubicle, or do you want to expand and I don't know, blow out of proportion and see the universe? That's a weird sentence, but it's I think you guys kind of understand the concept. Like, get out of the box, explore into more things.
Totally.
Yeah.
Mike, you were sort of chomping at the bit there.
Well, I mean, he's right. I mean, there might be a little bit higher chance of finding life on Europa and Enceladus, but I mean, I agree with Athena that we need to explore, but I mean, the other reason being for settlement. I'm definitely in that same philosophy that Elon Musk has, that we need a backup for our species, and that's something that we need to do. And that's another reason why I am usually say things just like, screw it, let's just go ahead and seed the planet and send a bunch of microbes and bacteria and let's start the terraforming process already. Who cares? I want humanity to have a secondary home. Anyway, but that's the other reason to go, but that's a very long, drawn-out goal. So,
I like how you said that, the backup for humanity.
Yep.
Like our backup plan. That's a good way to look at it.
Totally. This seemed to depress you, Jared.
What's up?
I'm concerned for you right now.
Well, no, it's just
you were you were the first person to nearly throw your hands up and you came away from the computer you were there's no reasoning with this guy. What's going through your head?
So the dinosaurs didn't have a space program.
And look what happened to them.
How'd that end for them?
That should just mic drop right there. That's a really valid point.
No,
Let's go
I'm serious. It's one of those
You're
things.
right.
The reason that we want to go to all these places is Elon said, backup. There is an I don't care what anybody says. There is an asteroid out there that is a couple miles across, and it's got our name on it, and it's going to hit us at some point in Earth's future. I have no idea when that is, and most of us who look for those kinds of things, of everything we know, we're all clear for the next 2 centuries. But something's going to hit us. There's going to be a major volcanic eruption at some point. We are doing an exceptional job of bringing upon a new extinction event ourselves on this planet.
Sure.
And we should definitely go to the moon and Mars as a backup. Our backup should have a backup. And to me, moon is where you definitely should have the backup at. Mars could be the backup to the backup, if you will, because I'm a moon firster.
Yeah, Takawe from our Twitch channel says, why wouldn't the moon be just as good as a backup?
Yeah, it would.
Do that too.
Yeah.
Also orbiting space colonies.
All of the
things. Exactly.
Get to the asteroid belt and even get onto the moons of Jupiter and Saturn. We need to do all those things.
Yeah,
we got to start somewhere.
Everything. Let's do everything. And we have to start somewhere. We basically have to pick something. I know Ben hates spin-offs and all the other stuff, but also these spin-offs enable a lot of the things that Ben really likes. So when Apollo started, Apollo was politically motivated. Let's not get around it. It was basically, our missile's bigger than yours, and we're going to put our missile to get people up there, and they're going to look down on you because we're better. And that's what it was. It was just, it had good PR, so a lot of people didn't realize what it was. But a lot of the technology that came out of Apollo was sort of not a known quantity at that time. It wasn't understood what a processor that could do multiple things at once was actually going to be able to do. It wasn't understood what the landing computer was going to eventually be able to do. It wasn't understood what a whole bunch of these optical systems that they developed for it was going to end up doing. But look what it ended up doing. It ended up bringing us, this is a direct descendant of some of the systems that they used during Project Apollo. So who knows what something from Mars is going to end up giving us, We don't know, and I think that is sort of one of the best things about it is that it's not so much the fact that we don't know what's going to end up happening. It's that those surprises that come out of it. That's the secret sauce that makes it awesome. So just like with the science work that we're doing, like with NASA InSight and with Bruce earlier today, true missions of discovery. That's the kind of stuff that really ends up doing it, and having humans go there and do that really helps us enable that both in learning about the places that we're at, learning about ourselves and sort of what we're made of in order to make these things happen, and the technology that allows us to do that. So,
Amazing.
Well said.
Very
that
well
was good.
said. Very well said.
That
All
was,
right.
though, yeah.
On that note, what I want to do now is make sure I give the thank you that I had already promised to our ground support citizens. These are the people who contributed $1 or more per episode on Patreon. They, of course, get their name in the show. They get access to our exclusive citizen-only hangouts, which, again, I had tons of fun, and early access to After Dark as soon as available on demand. And just one more reminder, as long as you're here, you might as well hit the subscribe button on YouTube and the notification bell.
What are you doing?
So you know when future live shows are happening. Please do that. Any case, if you are interested in all these things and so much more, head on over to patreon.com/TMRO. And next week, I don't know if you've heard.
I'm very excited about this.
I don't know. We have a returning guest. A returning guest.
Changing colors right now.
I want to be very clear about that. We're all very excited about that. We are going to have in studio,
right here, right here.
We are going to have.
Sorry, Mike. Sorry.
There you go. Exactly. We're going to have.
Wait, no, it's okay.
The one and only Mr. Peter Beck from Rocket Lab. If you're not familiar with Rocket Lab, please go familiarize yourself with Rocket Lab, first of all. But we're going to be talking with him about all different kinds of things.
I am shooketh
that
he is going to be here.
Their amazing launch site out in New Zealand. It's the most gorgeous launch site I've ever seen. The absolutely incredible Electron vehicle. The really amazing, it's business time socks. We're definitely talking about those socks. And really, really so much more. So
carbon fiber.
That is going to be a lot of fun. Again, like I said, he was a returning guest. I know some people are kind of saying, wait, what? We had Peter Beck on a long time ago, before things were like really completely completed, for lack of a better term. And that was an interesting interview then, and now it's great to have him back to be like, hey, so now you've done stuff. So that's cool. Let's talk about that for a while.
Tell us what you've done.
Yeah, really exciting. Really excited about that.
Impress me.
And like I said, in-studio guests. So please feel free to, submit some questions on community if you like, pre-questions. If you're unable to join us live, we will definitely be taking your questions, comments, concerns, complaints during the live show. But anything that you want to know from Mr. Peter Beck, please feel free to submit those here, there, and everywhere. And other than that, it's been a great show, and we're going to head into After Dark. See you guys next week. Bye.
You don't need sound.
We all were like, well, I mean, I guess like.
Like, why are we doing this time?
Like, wow.
Hi, Lisa.
Get over here.
Lisa.
Here, let me grab another chair.
Should we go get a stool?
Yeah, probably the tall one because she's short.
Which one's the tall one?
The white one.
Oh, okay.
Actually, I need to take up
wow.
I feel like if I make sounds, it feels not as heavy.
And Bruce, are you sticking around with us?
Yeah, sure.
Okay.
All right.
Awesome.
All right. We're all just going to hang out now.
Awesome. Because there was definitely questions in the chat room that did not exactly get answered.
Yeah, that's awesome. So, but I just want to give a little shout out to NASA, who's been working with us up at Griffith Observatory a lot. We're going to be collaborating on a live stream for Mars' Closest Approach on Monday night into Tuesday morning. So tune in, 10 p.m. Pacific Daylight Time, Monday to 2 a.m. Pacific Daylight Time Tuesday. Figure out what time that is wherever you are, because Mars' Closest Approach is happening at 12:35 a.m. Pacific Daylight Time here in Los Angeles. Mars will be directly overhead when that occurs.
Man, that's awesome.
So that means that for those of us in California and on this area right here, we're actually going to be the closest people to Mars.
That's really exciting.
Which I'm so excited about.
Are you guys just doing a live stream, or are you having people come to Griffith? Could I just show up?
We will be open to the public.
Yes,
the
that's a
outside,
terrible idea.
The interior of the building will not be. I'll just throw this out there to you, which is in 2003, the last time there was the closest approach. We had an event. 18,000 people descended upon the observatory.
So if you want to go, you should go now and just camp out.
Basically.
Okay.
Basically. So
is like the entire hill just filled with people?
Not just the entire hill, the entire neighborhood around.
I bet your neighbors love you for that.
The freeways within a mile and a half stopped.
Man.
So that's how big it was. So if you're, I would just watch it from home.
No, honestly,
I will be.
Monday night,
I'm working the stream, but I'm not going to be on it as far as I know. I'm going to be behind a camera working it. So
that's a shame.
But I will try to make as many jokes as I can to make my bosses laugh. So.
Good.
It's going to be good.
But yeah, I'm really excited about it.
Oh,
nice.
Man. I still want to go,
though. Mike, Athena, Lisa, did anybody have any questions for our guests that you guys didn't get a chance to, because Jared was the one asking all the questions.
Right. There was a lot of good questions that were pretty much answered.
What were you working on before the InSight lander?
Well, I was working on trying to get the InSight lander selected by NASA. That's been kind of my sort of #1 job for like 25 years. But to pay the bills, of course, I got to actually do something for other people. So I was the project scientist on the Mars exploration rovers for about 7 years, Spirit and Opportunity. I wasn't on the mission during launch and landing. I came on about a year and a half after it landed, and the project scientist for MER moved on to MSL, and I kind of, all the dominoes kind of went, and I kind of moved into that position. So I was project scientist on MER for a while, and before that I worked on Mars Global Surveyor. Oh man, that was a long time. It's from about 88 all the way through when it went dark in 2003, 2002. Worked on the laser altimeter experiment on MGS and Mars Observer before that.
Wow.
So,
So you're very well.
Yeah, and I got to play with Magellan for a while too.
Oh, cool!
Oh, wow.
Radar mapping at Venus. That's so cool. So you're
the InSight lander, my most favorite planet.
So you kind of have a close personal relationship with Mars.
Yeah. It's we all have our favorite children. We don't usually talk about it.
It's good. It's really good.
Oh, there's
since the InSight lander shares a lot of similarities to the Phoenix lander, how closely did you work with the people on that team? And were you involved with the Phoenix lander at the time of its mission?
I actually wasn't involved in Phoenix at all. It was completely independent. My scientific interest, which kind of fuels all this, is in the deep interiors of planets and their sort of long-term history and evolution. And Phoenix was very very tightly focused on the question of water ice at the poles and that sort of thing. So I really wasn't involved in that. Of course, being at JPL, you get to, you eat lunch at the table next to the people who are talking about, this issue or that problem and stuff. So you get a lot of kind of inside information, but and you're cheering them along. But I didn't work on Phoenix at all, which is kind of ironic since now I basically have a Phoenix spacecraft. But I tease the Phoenix people and say, that I'm really glad that they did a thorough checkout of my spacecraft, but now we'll do something really important.
Thanks for doing a demonstration mission for me.
Yeah, that's right.
This is a pretty funny question from the chat. I see from Kim McCoy. He says, "Is the team going to be living on Martian days for some part of the mission? Do you guys actually sync up your schedule with?" Yeah.
Actually, we're not. Like, this is going to be I think it's the first Mars landing mission that's not going to do that, and the reason is money, because if you're on Mars time, that means you have to be able to operate this. You're operating the spacecraft around the clock, which means you have to have an extra shift or two of people on the payroll, so that people can sleep, because it turns out that nobody can actually sync up on Mars time indefinitely. After a while, you just go insane and start doing crazy things and seeing, purple cows, floating across your computer screen.
Wait, that doesn't happen regularly?
Without drugs. And so, in order to keep our costs down, we decided to go on what we call modified Earth time, which means that we have 8 to 10 hour shifts that can start as early as 6 a.m. and can go as late as 11 p.m. And so it can kind of walk through the day, sort of following Mars time for a while. And then when we get to where it's late enough to where our uplink is too late, or our downlink comes down too late, we basically just pop back to a normal shift and skip every other day, because we don't get the information down from the spacecraft early enough to be able to put together a command load before it has to go back up to the spacecraft in the day. And so we go for about 3 weeks, 2.5 weeks, kind of walking through the day, and then we spend about a week, kind of going every other day, and then we have to reset our alarm clocks and get in at 6 o'clock in the morning again, kind of walk through the day again. So that ends up saving us millions of dollars. It turns out it's kind of crazy, but. So we don't get the cool, Mars watches, Mickey Mouse with the 24 hours and 30 minutes on it.
Wait, that sounds awesome.
Just have to go on eBay and pretend,
I think there was, if I remember correctly, like an actual set of Mars watches made for JPL, if I recall correctly.
Do you have one?
Absolutely. I don't have one, but I'm probably going to get one just to, like I said, so I can pretend like I was on Mars time. And honestly, I probably will end up being on Mars time for the first month or two. It's just it's hard to resist, going and see what's happening all the time.
That's kind of cool. I'm sort of tempted to do like a Mars time challenge, 21-day challenge. Go on Mars time.
I would do
create like a Mars calendar.
And see if you can touch your nose at the end. Yeah.
Between the purple cows and the Mickey Mouse watch dodging.
It was in.
That'd be a really good psyche challenge. Oh man, I would volunteer to do that for NASA. Like get some data collected and estimate how many people can survive to be Martians and adjust accordingly to the time. But yeah, that's interesting because there is a lot of like psychological suffering from that. What did you say? Have you actually experienced much of that, or putting all aside the joking?
I don't understand what you mean.
As far as, I know you were joking saying that seeing purple cows and everything, but have you actually experienced like some really crazy situations where going on Mars days, you'll feel really off?
No, I wasn't on a Mars surface project when it was on Mars time, so I've heard stories.
Okay.
Although I did I drove across the country a couple of times, and by the end I was seeing some weird things, without sleep. I mean, circadian rhythms are a really interesting subject of research, actually, but you should do it with a professional.
We should ask the standard questions. I would ask them. I don't have a microphone on, so.
Oh yeah, we didn't. Yeah. Unfortunately, we didn't get to ask the standard questions like we usually do. It's a set of questions that we ask every guest. There's no right or wrong ansers to it.
So it's like truth or dare kind of thing.
It's not like truth or dare. It's just more like would you want to just go into the questions and you can find out? So
yeah, let's just go into it. This is just it's just more of like it's almost like a poll of what we ask all of our guests.
Actually, Mike, do you want to do it?
You want to? Yeah, one virtual guest to another, sure.
It's the holograms.
The holograms will talk to each other. So.
There you go. I like it. God, he's gonna look at it too. I love it. Exactly. That's so good.
That's so good. So, you guys might have to help me out with this a little bit, but what is your favorite space mission, past, present, or future?
Favorite space mission?
Can be anything. No wrong answer.
I'd have to say Viking. Viking is my favorite space mission because I was actually at JPL as a student when Viking landed on Mars, and that was just even more to me, more than Apollo. Viking was like first spacecraft sat down on a planet, and that first image kind of came down kind of line by line by line, and you're sitting there seeing the rocks on Mars. I mean, you can kind of look up in the sky and you can almost see the rocks on the moon, and the moon's cool, but Mars was just another world, another whole planet that was just so incredible. And so, the fact that we'd actually sent something and a robot that landed all by itself on another planet. I mean, so Viking is I think my sentimental favorite.
Well, this might be a biased question to ask you, but do you think that we should explore the cosmos with humans, robots, or both?
Both, definitely. I think that, the only really deep, pure exploration has to be done with humans. And spending 7 years, with a robotic, a couple of robotic rovers on Mars, Spirit and Opportunity, it's so time-consuming and tedious to get anything done remotely on a planet with a robot. It's super cheap compared to sending humans. It's much safer, and you can do things that you might not want a human to do, like crawl down in a volcano or something like that. And so I think robots are definitely the first wave that you should send for exploration. And but without humans, you're never really going to get deeply into anything. I mean, a human can figure out, in 1 hour, a human can figure out stuff that would take, a year for a robot to. So it just doesn't make sense to do it without humans. But I'm definitely a big fan of robotic exploration. Don't get me wrong.
That seems to be a general consensus too, which is pretty cool. So.
Yeah.
Where do you think that we should explore next?
Well, I think that we should. I was listening to the discussion earlier about Mars versus Enceladus and Europa, and I think that again it's kind of an all of the above situation. Mars has a lot to tell us about the Earth, about the evolution of the inner solar system. And I think especially we have such a great data set on Mars that and we're kind of being able to get into deeper and deeper scientific questions. So I think it'd be a big mistake to kind of shut down Mars exploration. But meanwhile, Venus is almost pristine as far as exploration is concerned. There's and here we have the twin, sort of Earth's evil twin, that it's the same size and the same mass as the Earth, and yet the surface environment is so different, and the geological evolution has been so different if you start looking in details at the surface of Venus. And so I think Venus is someplace that we really need to start figuring out how we can get down and start doing some in situ exploration. Europa and Enceladus have so many mysterious things going on, and there's the tantalizing possibility of some kind of strange life living in the deep ocean beneath the icy surface. That's definitely someplace that humans should set their sights on exploring, and and on and on and on. I mean, the thing about exploration is there's you never reach the horizon. There's always some place to go. But that's kind of my personal priority, which is colored by my scientific interests and what I've been studying and curious about. It's kind of Mars, Venus, and Europa/Enceladus.
Awesome. Let's see. Did I forget any of the standard questions?
Why space?
Why space? The most important question we ask.
Yeah, kind of, but that's cool.
There's actually a politician, and I won't name him/her, but ask a colleague of mine once. It says, "What's the purpose of the planets?" And he was just kind of, "What's the purpose of the planets?" And so, okay, well, so why space? I mean, space is how you get to where you need to go. I mean, space is part of the universe around us, and that's like asking somebody that grew up in Maricopa, California, why go to L.A. or why go to New York or why go to France or why leave your backyard? I mean, you leave your backyard to learn new things about the universe you live in, and space is just kind of a logical extension of that.
Nice.
That was such a cool answer.
Awesome. Very cool.
Awesome.
No, that was really good.
Yeah.
That's well said.
And I didn't grow up in Maricopa, by the way. I mean, I grew up in town, which is much bigger.
Yeah, I was going to say, you have something against Maricopa. No, I'm just kidding.
Oh, that's good.
No. One question that I did have that isn't part of the standard questions is, as far as I know, there are pockets of magnetic fields that do pop out occasionally from the surface of Mars. Is InSight Lander going to be helped to understanding what that is and understanding, whether or not those are magnetic effects from some sort of ore, or if that's coming actually from the core itself? Or is that even true? Am I
contribute to that? I'm not actually an expert on magnetic fields, but we are actually landing kind of right on the edge of one of those what we call magnetic anomalies. One of the magnetic highs is just kind of off to the side of the InSight landing site. So we have people on our team who are interested in those magnetic anomalies, which appear to be generated within the crust from ore bodies, as you said. We definitely will be looking at the magnetic fields from the core, which have not unambiguously been detected. I mean, the magnetic fields that we've seen at Mars so far seem all to be from either just magnetized crust, which are just rocks that have a magnetic field frozen into them, or from currents in the ionosphere. And so one of the nice things about InSight is it's going to be stationary. So both the other magnetometers that have gone to Mars have been on orbiters, and so you have the motion of the orbiter that gets sort of involved with any variations in the magnetic field, and so we'll be able to look at the magnetic field from just a little bit different sort of dimensional space than orbiters do. At the same time that the magnetometer on Maven will be looking at it from space, and so actually having two magnetometers looking at at different scales is going to be extremely valuable in terms of being able to unravel the sort of the dynamic versus the static magnetic field of Mars.
Yeah,
wow, that's so awesome.
Those two sources, that's great.
We have a
question. I've often wondered whether or not those magnetic anomalies are strong enough for like any sort of habitats or anything like that. But anyway, that's
a really interesting theory. We had a question from the chat room. So who am I going to go with this one? Mike Kayansik on YouTube asks, how will InSight handle planetary-wide dust storms? Kind of like the one that Opportunity is going through at the moment.
That's a really good question, and we thought about that a lot and worked on that a lot, because the Phoenix spacecraft wasn't originally designed to worry about stuff like that. It was going to the polar region, and it was only supposed to last for 45 or 60 days or something. So we've taken the Phoenix spacecraft, and we need to use it as a long-lived lander. We want to last at least 2 years, 1 Mars year on the surface. And so we knew we had to deal with dust storms. So we did a couple of different things. First of all, in terms of landing on Mars, we knew we were going to be landing during dust storm season. And so we looked at, the effects of of dust on sandblasting the heat shield, and they did some experiments and some calculations, and based on that, we added about a ½ inch more ablative material to our heat shield than Phoenix had, and that should take care of the maximum amount of dust we might see in the atmosphere in terms of landing. Once we get on the surface, the problem with dust storms, of course, is they block out the sun, and when you block out the sun, your solar panels don't work as well. So we made our solar panels a little bit larger, about 6 inches in radius on each panel, which increased their output by about 15% or so, 15 or 20%, which helps. And the solar panels at the equator actually generate a lot more electricity than we need in kind of a normal situation, which gives us a lot of margin if the insolation goes down because of dust obscuration. And we actually also made put a special set of circuits in the spacecraft that we call the dead bus recovery system. And what that means is that if we get into a dust storm, which really blocks the sun for a long period of time, and our batteries just get completely depleted and get down below the voltage that can actually operate our electronics, everything shuts down, and the spacecraft basically goes into a coma. But we built it so that there's the power system is actually just open all the time. So when the sun comes back on the panels and starts pumping electrons through the system again, the power system will kind of self-boot itself and then start charging the batteries. And when the batteries get up, they'll reboot the spacecraft computer, and we're off to the races again. And so all we have to do is worry about how cold it gets in the meantime, because sometimes the really intense cold on Mars could cause failures in the electronics. So we always have a danger when that happens. But we actually designed the spacecraft with enough margin to survive any dust storm that had been seen on Mars up until our design point, which was the one that actually ended up killing Spirit, I guess. But it turns out this storm is, of course, more intense than that one, and would have probably put us into the dead bus state. But by the time we get there, this dust storm should be pretty much dissipated. So we can survive most dust storms, but there's every 25 or 50 years there's one that's gonna knock us out for a while. But even then, we have a chance of recovering if we get lucky.
That's so cool.
I'm really confused right now.
What you're doing is you're looking at our guest through the camera, but what's happening is that literally everybody else watching is getting freaked out because you're staring them down. As opposed to looking at the guest naturally on the TV.
I'll step in. So
then Ben gets behind the camera.
What you couldn't see is off camera. I walked in and I stood right by the screen and I just started
staring. And she immediately
staring.
Stops. She looks down really quickly.
Staring at Lisa intently, and she's like, "Oh God, I don't know what I'm doing wrong, but I'm not gonna look at Ben."
Oh man!
To be fair, I did not sleep very well last night. So.
This is true. And also, to be fair, Bruce, what you were saying was highly interesting. So I can totally see where you were captivated.
Yeah, especially with
in my head, I'm visualizing InSight with all these extra dust precautions.
So this storm, the current storm is like one of those 25 to 50 year storms. It's just it's absurd. Right. And if I remember right, this is the strongest, basically the strongest, or the opacity of the atmosphere is. This is the what is it? I think it's measured in something called tau, if I remember correctly.
That's right.
And this is they basically from Opportunity got the highest reading they've ever got from the surface of Mars, and then Opportunity turned off. So
right.
Yeah.
Yeah, the highest tau before was about 4.5 that they measured about 4 or 5 years ago, and normally tau is around 0.5 or maybe 1 on a kind of a hazy day, and 4.5 is pretty dim. And I think Opportunity measured something higher than 8 before it went offline. So this one is a really strong storm, and by strong storm I don't mean the Martian where things are blowing around and spacecraft are tipping over and stuff like that, because it's that's not the way it works. But what we measure storms in is how much dust gets lifted up into the atmosphere, and if you're actually on the planet, you might feel a gentle breeze, but that's about as violent as it gets.
Oh wait, really? You would just feel
a
breeze. Wow, because I was thinking what it's going to be like for humans.
Even like 100 meters per 100 kilometer per hour wind on Mars would feel like about 8 or 10 mile an hour wind on the Earth because of the atmospheric density difference.
Oh wow! Oh, I didn't know about that. That's really cool. So then, when it comes to considerations for the construction of Martian cities or whatever it is we're really going to be building there for humans to really be encapsulated in. That's interesting because I was thinking, oh my gosh, this is going to have to be super stable. It's probably going to have to be at least 50 floors deep, and the basement's all going to be really, really deep. And but that's interesting that it's going to be that light. I actually didn't realize that. I guess that's why also the rovers are...
Until we terraform it, of course.
Until we terraform it, yeah.
Hey, I wanted to ask you about the cameras on InSight. You said that there's context cameras to help you figure out where to put the seismometer, the seismometer and the heat flow probe. Are those the only cameras on board, or have you got other cameras?
No, we have 2 cameras on board. One is, and they're both actually spare cameras from Curiosity. One's what we call the nav cam, which is the wide angle, 120-degree field of view that gives kind of a distorted picture, but you can see, all around. And we have that hard mounted below the deck that shows basically the entire area that the arm can reach, all in one frame. And so that's a really good guide for us to figuring out, where to put our instruments. And then the other camera is a nav cam. So we've got the HAZ cam below. We got the nav cam. It's actually attached to the robot arm. And so instead of having a separate mast with motors and things to point it, we actually just attach it to the robot arm, and we just point to what we want to look at with the arm.
That's cool.
And then we can take a picture. And so it's a little bit higher resolution and a narrower field of view to take a little bit more well-defined pictures of spots, and we can put together mosaic of that'll show our thing. The difference with Curiosity is we actually took them apart and put a color filter on over the detector. So instead of having black and white, we actually have full color pictures of with our nav cam and HAZ cam. So that'll be cool too.
That's gonna be sweet. So are you guys gonna literally move the robotic arm around in order to just take panoramas and stuff? So cool.
At one point, we're just going to take a full 360-degree panorama in stereo and color.
In 4K?
And it'll probably take months to download it, but it'll be awesome.
Are you guys also planning on taking pictures of the materials that the lander's made out of to see how it's holding up on the surface of Mars?
Yeah. We'll take deck pictures as well. In fact, we have our calibration target is over on one side of the deck, and so we'll be taking sort of regular pictures of that and be able to look at dust accumulation and any kind of either erosion from windblown dust or degradation from ultraviolet or cosmic radiation, stuff like that.
Nice. One thing I did forget to talk about during the interview, which I thought was really cool, is that you guys have several microchips on board of InSight that has people's names, right?
That's right. We have 2 of them because we have one that we put together during the 2016 launch campaign, and then when we didn't launch, we said, well, we might as well open it up again for another one. And so we got I think we ended up with 2.3 million names between the 2 chips.
Sweet.
And they're glued onto the deck right next to our calibration target. So we're going to take pictures of people's names every few weeks on Mars as well.
Wow, that's so cool.
Really cool.
Yeah, my name's on the 2016 one, I think, and I got my little passport to Mars too, which we just had a photo of some folks there with theirs in front of InSight.
That's actually me on the right, and my project manager Tom Hoffman on the left with our boarding passes to go to Mars.
I love it.
So you submit your name, you get a boarding pass. So
Yeah,
you can
excellent.
accumulate frequent flyer miles. All the Mars missions.
I think you need one of
I would
those.
get platinum status if I went to Mars.
Yep.
You need one of those by 2020 to fly, right? Anyways.
We'll definitely need one of those passports.
That's amazing.
Wow. That's really, really cool. Pictures. What about selfies?
I have another question. After you get a bunch of data back from InSight, what is your next objective? What's next for you? Are you planning another type of mission to Mars? Is there other questions that you want to ask that this mission isn't hopefully going to be answering? And is there a possibility of another slew of possibilities depending on what this mission's results are?
Well, I'm not sure I have another 25 years to get another mission going off the drawing board. But eventually, what we would like to do from a geophysical standpoint, from an interior standpoint, is have multiple stations on the planet. So I would love to send a seismometer with every mission that goes down to the surface. because there's things you can do with seismology with multiple stations that you just can't do with one. I mean, we can get sort of a reconnaissance of the planet, get the sort of the major divisions of the interior, but to really start asking some of the detailed questions about the origin of Mars volcanism, how the depth at which the magmas are generated, things like that. You really start needing to get multiple stations, and I'd love to advocate for getting some more seismometers on Mars. Past that, I would love to see a mission go back to Venus and start answering some of our questions about the age of some of those surface features, the composition of the interior, whether the mantle of Venus is dry or whether it has a lot of water that's dissolved in it. That's kind of a basic question that goes into whether plate tectonics could ever occur on Venus, and whether the atmosphere could ever turn into something that was not some kind of a hellish greenhouse and could actually support a life as we understand it. So I think a Venus exploration mission is really long overdue. And meanwhile, I'm just watching these missions to OSIRIS-REx is going to be bringing back a sample of an asteroid pretty soon. We've got a Psyche mission going to a fragment of a planetary core. I mean, there's lots of missions already that are either being built or operating that are going to be super fascinating. So I'm just sitting back and it's just as a planetary scientist, sometimes I feel like a kid in a candy store. I mean, we're really in the middle of the golden age of planetary exploration right now.
We really are. Yeah.
Regarding Venus, what do you think about the ideas of the floating colonies in the upper atmosphere of Venus? Do you think that's a viable thing?
I have no idea. Sounds cool. I'd say people have a habit of solving those kinds of problems if they really set their minds to it. I mean, that's one thing I've really learned working with the engineering team, at JPL and Lockheed Martin and our instrument partners is, every week we come up with some problem and I'm going, oh my God, that's a showstopper. I don't see how we can possibly get by that. And then, there's some guy or some girl somewhere who's like, oh, I know how we can fix that. You just do this and this and this and this. And I'm going, oh my God, that's perfect. And so human ingenuity is just incredibly deep. I mean, so yeah, floating colonies on Venus, why not?
That's awesome.
Yeah. JPL seems like it's got the right people in the right environment to do those right things, and that's amazing.
Yeah.
So
it's an amazing place to work. And I worked there for over 40 years now, and I had no idea that it was as good as it is until I was in charge of this mission and like I said, trying to solve some of these problems. And there's always somebody somewhere who was an expert on the thing we needed to know about, and they go, oh yeah, you just do this. And I'm going, whoa, that's just having world experts at basically any kind of a subject that you can think of is just amazing.
Beautiful. Well, Bruce, it was really amazing having you on, and maybe a little bit in the future once InSight is going, or InSight is going. What am I trying to say?
Has landed.
Thank you. That's what I wanted. If you wouldn't mind maybe coming back and then giving us some updates and thoughts, feelings, experiences of how that all went for you. I think that would be really cool. If you don't, assuming you had a nice time here.
Yeah.
All right, cool.
We'll definitely have to set that up.
Yeah, yes. Awesome. Perfect. Well, that's about us. It for us this week. We have a lot of work we need to get done. We have an entire green room that we have to get ready for Mr. Peter Beck is coming in town, and so we got some stuff we got to clean up. So again, thank you to Bruce, Jared, great interview, Mike, Athena, Lisa, thank you for hanging out, everybody here in studio, of course, and to all of you, thank you for joining us. We will see you guys next week. Have a good one.
See you next week.
Bye.